that if you were dealing with people with mental health issues, you would actually be like demigrating them. You would be actually like inflicting more harm than good.
Now, it
Uh,
would help. It would help actually if when a flat earther made a claim about something, right? And they said, "Well, we think these measurements are like this, and we think the Earth is like this," and we said, "No, no, no, no. Let me explain to you why you're wrong. Let me show you why you're wrong." Instead of just them just saying, "Well, I don't want to believe that because I think space is fake. I think this and this and that. I think the government is behind this and this and that," and just dismissing all evidence. Then we would,
Do
you
you
know,
think there's no
yes,
good reason why people think the way they do? I mean, everyone's got their discernment and their excuses and reasons, and
I mean,
there is another side to the story if you look into the evidence.
but we don't
sure,
care
but
about. You don't need the fucking government to figure out the fucking shape of the Earth.
that part's true, yes. So to answer your question, it was like, do you have any examples of like, you being empathetic or whatever the fuck? So way in the
I was
past,
a
we don't.
glober like you once before. I was like you.
We've heard this.
Congratulations. So you were correct for a moment, and then thought being correct was not your style. Congratulations. I'm not impressed by
Right.
that. So anyway, as I was saying, yes, that we have dipped into that philosophical conundrum before, back in the day when I was doing Dumb Fuck of the Year. It was an award that we awarded to the person that was the biggest dumb fuck, but there was one rule, and the rule was you had to be a dumb fuck by choice, not disability. If you were a dumb fuck by disability, you were disqualified because that's not a true, genuine dumb fuck. However, it's become very, very hard to differentiate between those who are a dumb fuck by choice and a dumb fuck by disability. It's really, really difficult because it just blends in. And of course, it's a judgment call. You have to make that judgment call. And I do not think that you are suffering from any sort of mental issues. I don't think you're suffering from any sort of trauma or anything like that. I might be wrong. I'm not an expert in this. But going on that assumption, the only thing I can say is that you're just wrong and I can correct you without feeling bad about it.
There's one axiom though. There's an axiom though, and that is that when humans get older, the older they get, the more lessons they learn, the more discernment they gain, and they get wiser. And that is an Occam's razor axiom. So if you want to look at it like going from a globe Earth perception into another perception by your discernment, your wisdom, your experience, I think that should be logical. That should be outweighing the idea that the world is a heliocentric water ball spinning in a vacuum.
Sure, but until the dementia kicks in, right? And so what we have here is that we have a whole bunch of people. I look at this, and part of it is that I like the challenge. It's like, okay, you believe this thing that I'm going to claim is a conspiracy that's not real, and I can say, all right, bullshit, but I can't just call bullshit. I have to be able to demonstrate it myself. And so what I've done as a hobby is I've built up an arsenal of evidence through my own efforts, through my own work, to throw it at you. So when you say, how do you know that the Earth is round? I can come back to you with evidence not from NASA, JAXA, ESA, SpaceX, Roscosmos, Sierra Nevada Corporation, or any other the fuck ton of entities that the coin needed to get their asses to orbit. I can show you my own work. So you can't pivot to, well, you're just believing a story told to you by the nameless, faceless they. And that's where the second part of my satisfaction comes in, is I like to witness the mental gymnastics people do to get away from the facts that I have found myself. That can be verified by anybody who cares to do so. I find pleasure in that. Is that a problem on my part? Probably, but it's not a problem I'm looking to fix. I'm enjoying myself. And that makes me a bad man, so be it. I'm a bad man. I'm a bad boy.
I feel sorry for you.
Cool. So anyway, hi Icy Spin, how's it going?
Oh, Brads, how are you, man? Learn anything today?
Yeah, true story. I was actually accused of being you once upon a time. And the fact that we're having this conversation right now means we're not the same person, right?
That's pretty wild. Who said that?
That's pretty wild. And so we're talking at the same time, which means that I can't be you, possibly, right?
Yeah, and I'm not nearly as clever as you are. So I mean, who made that stupid mistake?
And I got to
tell you, it real quick. Can I test it?
I got your ability to bring me chocolate milk is second to none.
That's right. 2 Nesquiks, I remember, because I am you.
Can I test it
Yeah,
real
what's
quick?
up? Is this Andrew, right?
All right,
What's
I'm
up,
going to give
Andrew?
you a very simple math question. I want one of you to give the correct answer, one of you to give the wrong answer. Doesn't matter who it is. Okay.
Mm-hmm.
What is the square root of 144?
69.
12.
That wasn't all right. I should have
Nailed
prefaced
it.
that a little bit better.
12.
Okay. A little delayed.
You didn't
All right.
say whether or not we said the incorrect one first, because that's how we're programmed.
Well, I
right?
said at the same time.
69 was funny. 69 was funny, though.
It was.
Yeah, okay, but that's 4,100 and something, I think, right? Well,
I don't know. I'm not programmed to understand that.
I don't know. I don't give a shit, really.
Well, anyway, so Icy Spin, since it is clear that you are not me, and only you can deliver those chocolate milks like a fucking champ, and I also wouldn't be caught dead driving a car with broken taillights.
Yeah, and I similarly wouldn't be caught dead. What am I talking about, dude? I mean, you're perfect. Like, give me a break. I can't come up with anything.
That's weird. It's gay.
Oh, stop, Andy.
That's just not making it better.
I mean, honestly, Andrew, you should see a shampoo together.
If that happened, I would see an optometrist to have something. Yeah, no.
Optometrist.
I'd be in therapy for a long time.
Optometrist.
You think that's bad? You should check out my OnlyFans. I'll send you a link.
Nope.
Optometrist.
Actually, last thing I have to say, and then I have to get back into work. I went to
you meant
OnlyFans
you meant
'cause I'd never been there
proctologist.
before.
Yeah, go ahead. Sorry.
Oh, probably multiple doctors. Yeah.
I need you to bend over and cough.
I went to
pleasure,
OnlyFans because
doctor.
I had never been there before. Everyone keeps talking about how like there's all these porn stars and whatnot. And I was like, oh, what the fuck is this all about? And I don't have an account there or anything. And it was just a whole bunch of people about gardening and physical fitness and meditation. And I was like, where the fuck is all the porn then? I guess you have to like have some sort of a special in to it. I don't know how it works. Don't really care, but I guess it is what it is.
Don't worry, I can show you the ropes one of these days. Just make sure your wife isn't in the room.
No, I prefer not.
Air quotes around the word ropes. Yeah.
Hey, Revs.
Yes, go ahead.
If you had to put a percentage on it, just linked to what you were saying earlier, if you right now had to put a percentage of what, in your mind, what likelihood that the Earth actually is planar and stationary, just that alone, like even leaving out the stars, everything else, just that the Earth, the geometry is actually planar, the sky is above, the ground is the ground, and that we're on a plane of existence. In your view, what is the percentage of that? Just the ground part. Like, I'm not trying to say how the whole model works or the whole sky or whether you've put it all together. I'm not saying that. I'm just saying what percentage in your mind right now is that the truth is that the actual ground is planar and is at rest and is stationary, and then the sky is in motion.
I don't know, 0.0000001% maybe. It would be some astronomically small number.
Well, we had how many zeros in there? 6, 7, 5? How many?
Something like that. Something like that.
Counted 42.
5 or 6.
40,
Okay, so not
42,
like
right?
10 to the negative 17 number of zeros. Like not that.
You know, that's actually very creative. I like that. I'm going to go with that answer.
Yeah,
that's actually very creative.
What about you, Gio? You're on the opposite side. Like, would you say the same about a globe? Like, you wouldn't have that low of a probability, right?
Well, that's an interesting question.
I guess.
I would almost say, well, go ahead.
I guess, you know, with percentages and wise is that to answer your question in a more thorough way, Gio, I just know too much shit, honestly. You know, whenever I was one true thing that a flat earther said was that I was taking a lot of shit for granted. And I was like, yeah, you're probably right. You're probably right. I haven't done the investigations myself. I haven't done the measurements myself. I haven't really gotten off my ass to do much of anything. That was back in like 2015, and the guy's name was JC Camby. You probably know him better as Jeranism. And you know that meme? It's like, and I took that personally. But now, after having done the work that I've done, and with the equipment that I now am privileged to own, and all that good shit, and knowing the cool ass people that I've met while doing this crazy shit, I know too much, and that's why the flat earth has such a remarkably low percentage. The only way for me to accept that it's even possible for, as you said, the earth to be flat or just the ground part to be flat is for literally me to be plugged into the matrix and the Matrix was just fucking with me the entire time. That would be the only scenario where that would even remotely be a possibility. Since I can't really say for sure that I'm not a brain in a vat that's plugged into the Matrix, that's where the low percentage comes in, and it's not just flat zero.
Well, let me ask you this. So with the sky observations, I understand that, that is what it is. Now, it could be like, let's just say for a moment, it's like a magic show up there, just as a funny thing to say. Like, let's just say like we can't fully discern what it is. We see it, and just for the moment, just for the conversation, if we just set all of that aside, in terms of the sky, even if, okay, let's just take it all out for the moment. When it comes to the ground, is everything you have, would you say it's like first order that the ground is curving, first order type measurements or observations, or some verification for yourself? Or is it sort of second order, third order? Like there's that idea of like primary knowledge, which is like something you got yourself. Then there's secondary, tertiary, etc. So let's say it's like either secondary or tertiary, meaning you heard it from someone else, or you heard it from someone else who they heard it from someone else, etc. And how that can break down scientifically and so on. So when it comes to the ground, like, would you say you have any like first order things that don't require assumptions and so on, in terms of that the ground is actually curving at that rate and water is as well?
Well, we have to be very careful with the word "no" there, because I know that can be very sticky. Just ask say Montreal whenever he's in here. He always gets anal about the word knowing. So if I'm going to define knowing as being of the highest confidence in something, then using that definition, I'm going to say, yes, I do know for a fact that the Earth is round, and that is based on information that I've been able to gather myself. Now, first order, second order, third order, that again means different things to different people. So let's say first order is things that you have done yourself. Second order would be things that you are taking from other people, like you can understand their methodology, you can go through the math of their methodology, but you haven't actually performed the methodology yourself. If that's defined as second order, so when I started out, it was only second order. When I was doing this, I was just trying to understand how other people that had the coin necessary to do this awesome shit was actually doing it. So I looked at how they were doing things. Then when I became privileged enough to get some equipment on my own, that's when it transitioned to more first order evidence. And so when I had my debate against Jeranism, I only presented evidence that I gathered myself. There were, or it was evidence of those like me that did similar things. So if I showed, like, for example, a multiple sunrise video from one individual, I would have had to have done it myself in order for me to present it in that debate. That's when it slowly transitioned over a number of years to first order.
Well, yeah. Well, there's like first order measurements, second order, and so on. But then there's also like primary knowledge, secondary, and tertiary. So, but I hear what you're saying with all that. Yeah, I mean, I followed everything. But you're right. It depends on how we define these words and like the exact way that it's perceived. Okay, then maybe just like, and this is kind of more of like an interview style. I'm not really even trying to debate necessarily, but okay, then of those things, like what would you say? I mean, I know you've presented different things, like the observations of the things in the sky and so on, and the ISS and all these things. And I'm not, I mean, earlier I was joking saying like, let's just pretend that's all a magic show up there. But I mean, the part of that could be the case, like I do think that the entities deceiving us about what the Earth is, I do think that they could put lights in the sky that would mimic, let's say, an ISS, whatever that thing is, and it not actually be the ISS. Or even that Artemis thing, like I think that could have been something that they did purposefully. So like to me, that's not out of the question that they could orchestrate that. So to me, like that wouldn't really confirm anything about their model in a way. But I understand for those arguments for you would be compelling, or you said they are compelling to you. But I'm just saying, can you also see why they might not be on the other hand? Because I mean, with the amount of money that the government military has, they could definitely have lights in the sky doing things, to copy their, like a magic show would in that way.
Geo, come on. You really think that's possible for the government to hide the shit?
Yeah, of course. If they're gonna do the whole like Artemis, kind of hoax type thing, they would definitely put a light that someone on the ground who's a civilian would be able to check it, because that would be part of the whole thing to convince them that it confirms the globe in some way, even though they're just putting that light artificially.
And don't you think millions of people would be checking that and confirming that, wait a minute, that light's not doing what it's supposed to be doing? That light's not as far
They
as
make
it's
it
saying.
match they make it match the story they're telling, the physics that they're claiming.
How
Therefore,
would they just
someone
make
could buy
it
a
match,
telescope.
yo?
Someone on the ground could buy a telescope and do it and then think they're confirming it. But meanwhile, it's just the government
would
military
be
complex putting it up there.
it would be a little bit complicated than that, because the idea is that you would have to do more than just put a light in the sky that is observable to a telescope. It would also have to be observable at the correct angles, thus the problem of
Right.
parallax comes out. Because when Astronomy Live was able to measure the distance to the Artemis spacecraft, the Orion spacecraft, he did so from multiple telescopes spaced apart by thousands of miles. And the parallax value it made sense compared to what NASA is saying. So if they had the technology of launching something into space and giving us this show, then they would have the technology to do it for real. There would be no reason for them to brute force to a conspiracy. That'd be like someone saying, "Hey, we should fake the footage of the fake moon mission on the moon." It wouldn't make any sense to do it that way, considering
No,
that the
it's
main cost of the whole operation is the massive rocket, which you would have to build anyway.
Well, it's funny. I said I wasn't going to debate, but now I almost went into that because I had mentioned what I was really going to ask you is what of the primary knowledge or first order measurement type things that you've done. That's why I jumped to this observation of the Artemis, because I know that's
Oh,
one of the
like
ones
what's the most convincing?
ISS, etc. That was really the original question, but then I kind of went into it because I brought that one up, and then B-Ball jumped in, and then I got sort of debating him or whatever a little bit. But that's fine. We don't have to go into that style. But either way, well, that was going to be my question. I know one of them is your Artemis footage and the ISS. That's why I mentioned those observations of those things. And when I mentioned the magic show part, I wasn't really referring to like Saturn necessarily. I think Saturn is actually part of the, quintessence of the ether at the high levels of this realm. So those are real things. Those are not like some government planted things. There is actually some people have a theory of that the planets were like, but anyways, leaving that aside, I think those are like part of nature. But these things, the Artemis, the other like quote unquote satellite, the lights that are blinking and things like that, the idea would just be that it's all happening in a much more local environment, at least local compared to like hundreds of thousands of miles, like not that far, all within, let's just say 10,000 miles just to leave a big range, like more like something like that local, to where they would just have to simulate the positions of things to then match the model that they're claiming is actually happening of things orbiting around a sphere. So that's more what I'm referring to. It's just that it wouldn't actually be going 236,000 miles around the moon or whatever. They would just simulate the light, in the sky for observers to be able to see it. So, I mean, that was kind of more the idea.
Well, I think what you were asking me was, what work have I done myself that was the most convincing of my position?
Of primary, yeah, because couldn't it always have an assumption ultimately?
Well, that's the whole idea of doing repeat observations with better, more clearly defined goals, is that you get
Yeah.
rid of as many assumptions as possible. And so when we measured the distance to the sun, it was imperative that we don't just take, for example, Kepler's third law on by faith. We had to actually verify that in order for it to be utilized within our measurements. So we said, okay, since Kepler's third law is an intrinsic part of the process, we need to verify that on our own. And so if you go through the entirety of the explanation and the measurements and everything like that, it's all our own work, except for two pieces of information that can be independently verified. And those two pieces of information is the historical data going back to the 1950s and the angular size, largest at opposition and smallest at opposition. But those two secondary ones, the opposition angular size thing, is going to be this year or next year in February 2027 is the smallest size that it's going to be seen, and then in 2035.
As what? The moon or the sun or what?
No. The angular size, is going to be like 26 arc seconds wide at its closest point during opposition, and only 14 arc seconds wide at its furthest point during opposition. So we found examples of that from amateur astronomers that had nothing to do with any government agency. They just do this shit for fun, like me and Astronomy Live. So we took their data.
The angular size of what?
Mars.
Oh, okay, Mars. Okay, sorry, go ahead.
So we took their data and we implemented it into our measurements. So you could say that we're taking their word for it. That was an assumption that they're telling us the truth and they're not just full of shit. But we will be able to close that gap at least by 2035. And I would be, if I were a betting man, I'd be betting that they were telling the truth when they took their measurements. So when it comes to other things, like, for example, measuring the distance to Mars and the angular size of Mars and then the actual size of Mars, that was all our own work. No assumptions whatsoever were utilized when making that determination. The altitude, size, and speed of the International Space Station, no assumptions were made when making that determination. Angular size of the sun and how it doesn't change throughout the day, no assumptions were made during that determination, and so on and so forth.
Yeah, those are like, I mean, what you're referring to, the angular size, would be that like circular region in the sky that what they're calling the planet or the sun or the moon takes up. So yeah, that's like an astronomical kinematic just reality. Now, to the best of your ability to measure it, obviously, and obviously refraction or scintillation or other should all be considered. But no, I agree. That's just like the kinematic actual astronomical specifics of the degree of what it's actually taking up in the sky. So yeah, that part doesn't have any theories.
That can be figured out by a single observer.
But then it does that has to be extrapolated into a larger theory, though, of a heliocentric type model. You know,
No, it doesn't.
Astronomical.
No, it doesn't. That's it's its own thing. It has its own merits in which it can stand on, regardless if the heliocentric model is true or if the geocentric model is true. Angular size is its own thing that has no bearing on any sort of particular orbital model that you wish to assume for the sake of argument.
No, I know.
Parallax also doesn't care.
The positioning is just the actual kinematics of it. No, I agree that those are not related, but I'm saying if someone's going to take those angular size changes, though, and then apply some kind of ratio to it and then claim that that shows that they are, you know, that Mars and the oppositions, like you said, when it's through, it's the idea of it orbiting around the sun, then you do have to extrapolate some concepts to take it to that, is what I'm saying, the angular size, because that's what you were alluding to the primary first order type of observation, right?
We were talking about just distance at the time of measurement and its actual size at the time of measurement, not its orbit. Its orbit was determined via Kepler's third law, which was also independently verified because we were using satellites around the Earth to stress test Kepler's third law to see if it actually turned out to be the case. And when we tested Kepler's third law, which depends on Newton's ideas to be coherent, then it worked. It passed the test. And so when we utilize Kepler's third law in this particular scenario, the only thing that would make sense without any contradictions whatsoever is if the sun is in the middle.
Well, but I mean, it can all be viewed as geocentric and it's equivalent. But I mean, are you saying there's some way that you feel like it's exclusive? That
it is exclusive because
what is the exclusivity idea there that you have?
I appreciate you asking that question. The exclusivity is the idea that contradictory entities or models do not exist. And where's the contradiction? If you were to place the Earth at the center of the universe, and Kepler's third law was deemed to be the way things work, as we were able to independently demonstrate, then it states that if an object is further away from a particular central body that it's orbiting, then it will orbit at a particular rate that there's a relationship between the distance and its orbital period. Geocentrism, however, requires everything to orbit around us within roughly the same amount of time. But that would require Earth to be many different masses all at the exact same time, dependent on the position of multiple different altitudes. Now, obviously, a thing can't be one thing and another thing, i.e. it can't be one mass and a different mass at the exact same time. That's a contradiction. So therefore, the entire geocentric concept is based on a contradiction.
Boom. I only came at the end there, but I appreciate that.
I believe Cool Hard Logic made a video about that particular problem with geocentrism before, but, you know, 'tis what it is.
Wait, sorry, I was like listening, but I was kind of away for a second. Would you mind repeating that? You're talking about Kepler's third law, and then this is something that... are you talking about geocentrism, like a globe-centered, or what are you referring to?
Well, I think that's what we mean when we say geocentric. Geocentric is it's not the Earth that moves around the sun, it's everything else that moves around the Earth. Isn't that what geocentrism is?
Well, globe geocentrism, yeah.
I don't think flat earthers would call themselves geocentrists, they would just call themselves flat earthers, would they not?
No, because the word
There's-
flat earther is just kind of some modern, like, seems like probably the CIA, FBI had something to do with that, kind of putting that into the as like a meme almost. Because I mean, what humans would have always had since the dawn of time before the globe was basically like a 3-layered world in a sense. Now, whether the whole thing is encompassed in a sphere or it's infinite, that's like for maybe metaphysical, spiritual idea. But that there is 3 layers. You have the upper world or the heavens, the celestials, etc. You have the physical plane of existence that we live on. Then you have essentially the underworld or under the earth, deep in the oceans.
Then we were
You know,
talking about
etc.
different things then. So you weren't talking
So
about geocentrism
geocentrism,
in the classical sense.
well, I mean, there's the globe geocentrism idea, but then I think just even before the globe, like geocentrism would just be interpreted as the Earth is in the center. I mean, it's sort of like if you have a hamburger, you got the bun on the top, that's like the heavens. You got the meat, that's the Earth. The bun on the bottom is like the underworld. But it would, so geocentric, like Earth centric, would be the Earth is at the center, hung between the upper heavens and the underworld or whatever you would call it, or the depths below us.
So not geocentric in the classical sense, as in everything goes around Earth, but geocentric in the sense that if we're talking like reality is a hamburger, as you so eloquently put it, we would be the patty.
Well, it's just a 3-layered, like all the ancient like shamanic cosmologies.
Well,
like
besides making me really, really fucking hungry, that would be a model that would be something that all I could say was it wasn't detected within our measurements, because in order for such a thing to be the case, then that would also have to be the case for not just what we observe above our head, but how we observe it, how we measure it. So if I'm looking at a particular star in a particular direction, like the North Celestial Pole, for example, the angle at which I see it would have to be consistent with a flat surface, and we don't see that. Because even in that particular model, the hamburger model that you're bringing up, we would expect to see 2 things. One, the altitude of the North Celestial Pole would be consistent with a flat surface, and 2, we would see large circular angular size shifts between different latitudes, and we don't see that. Regardless what latitude you're on, the circle of Polaris, for example, is always going to be the same angular diameter, regardless where you are on Earth. And in the flat Earth hamburger patty model, that would not be the case. The circles would actually change in diameters.
Well, I'm not okay. So first of all, in terms of the hamburger kind of idea, that was just like a visual kind of idea. But if you have like an upper world and a lower world, and then the earthly plane, the sky, I'm not referring to Polaris being at like the center of like the idea of like the cosmic egg, or like a planisphere where you have a plane in the center of a sphere. So if the plane's in a center of a sphere and you're looking up at like, let's say the upper hemispherical part of it, now that may or may not be happening on a much larger scale, but I'm not referring to some idea that like Polaris is just at the center of that and it's just some radial thing like that. I think the sky is like a toroidal sky. Like it's a double toroid. It's all above us and it manifests the way it manifests, and we're on a planar surface. So like whatever the shape of the whole hamburger top would be, or whatever, like in the hamburger idea, whatever the shape, like the 2 poles are in that, is what I'm suggesting. The 2 poles are in that, whatever that, if it is a larger dome or if it's infinite, like let's either one. But whatever that is, is just that larger question. But the 2 poles that we see and the equatorial stars would all be seen from that plane, from it, like in the hamburger patty idea, from the plane looking up, the 2 poles.
I guess the question I would have is, after coming up with a particular concept and a particular, let's say, a model of reality that you believe may be closer to the truth, how would you go about testing it, or how would you recommend other people go about testing your model, your hypothesis for the way things would be? If I brought my equipment out with me, what measurement would that equipment have to make in order to either confirm what you're saying or to refute what you're saying?
Yeah, that's a very good question. And I realize the whole scientific paradigm is very strong. And although I do think they're wrong about the shape, I also, realize that it's a whole system that you'd have to prove it, basically, is what I'm saying. Like, it'd have to be proven. So that's a huge question. I mean, there's a whole bunch of curvature tests, Earth measurement tests that need to be done, additional work with gyroscopes. If that's kind of what you're starting to, in terms of actually validating this, like if we're talking about Earth is a plane and the sky is a 2-pole system above us, then the scientific paradigm obviously sees it very, very differently. And so if you're asking like what evidence or what tests or what measurements would have to be done, to actually shift the whole paradigm to this being the truth. Is that what you're saying? Or
Yeah, what would you, so if you put forward a particular model and I said, okay, I'm willing to gather evidence out there in reality, what tests would you want me to do? And what measurements would be outside the realm of your model? So for example, if your model made a particular prediction and I got a particular measurement, how would you know that the measurements either agreed or disagreed with your particular model?
Yeah. So there's a bunch of angles. First of all, there's like tangible physical curvature tests of water and of land. There's all that category. And then there's the whole so there's that entire category. Even replicating something like LIGO to get a straight material to compare to the curvature of Earth, let's say, that is allegedly there. So like there's that whole family of tests. There's all the distance tests, like distance alone can do it. You know, if you have 4 points, for example, that are large enough, and you measure. Now, my issue there is we need to do tangible measurements though on the ground. Or, I mean, there's like LiDAR and other technologies I'm obviously open to using, but we can't, like, I'm not saying just going off of Google, but actually measuring ground distances, because distances alone will determine, especially if you have like 4 points, let's say, that are far enough apart, it'll determine whether the surface is planar or whether it's spherical. And then in addition to that, there's the whole category of doing angles to stars and then plotting GPs on the ground and then drawing circles of equal altitude and then literally doing hundreds, if not even thousands of those. And as you do all those angles to all those stars and all those circles of equal altitude, that's another way to do it. And the distances are involved in that. That's why I bring it in here, because when you have the GPs and the circle of equal altitude, you know, hundreds of them or even thousands, this is how they used to map, and this is how you map the Earth with the sky. But once you get all those angles, all those circles of equal altitude are either going to be coplanar or they're going to actually fit around a sphere. So that will do it too. And then the distances are linked to that because you have the distances that are all between the GPs, which will also be coplanar distances or spherical. So this actually could all be done in the real world. It's all like at our fingertips to do, you know, once the time is ready for that to happen. But those are just two categories. I could go on and on, but I'll pass the mic because I said a lot there. But those are some of the whole categories of it.
Okay, so you were saying primarily it would be ground measurements. Basically, you would want some sort of measurement of the ground, and I'm assuming visual stuff would not be sufficient for you personally. Am I correct in saying that?
Well, I think visual is very useful and is a great conversation and is a great thing to have, and we should keep doing as much as we can, I think, in that whole world, just as a human race, of the optics. But ultimately, if we're going to change the whole paradigm that the Earth isn't actually a sphere, I realize what we're up against just in terms of the mainstream structure and everything going on, let alone the financial, governmental, military, it's all connected. So yeah, I mean, we've always talked about having a tangible measurement. Yeah, something that is physical, tangible, that you can touch, even have it as like a monument where people could come visit. So like scientists from all around the world who are interested could actually come, touch it. They could bring their tools. They could do whatever they want to verify it, a tangible measurement. And whether that's compared with standing water or with the ground, either way, something like that where people could come and actually observe it themselves. And at that point, it would only be a matter of time. I mean, if it did tangibly show that the Earth isn't curving, but then you'd have to have several of them around the world. But I mean, that's one whole angle of it. But yeah, having it be tangible, I think is going to be required in my viewpoint. I don't think optics are going to I mean, there'll be more that it can happen, but it's not going to shift the whole paradigm.
So if I were to present to you optical measurements and angles and stuff like that, and theodolites and stuff with telescopes, for you personally, is it safe to say, is it fair to say that would never, ever be enough?
No, not necessarily, because I make arguments about plane surveying and how accurate plane surveying is, like within a couple millimeters, within a mile, for example, and you totally should be able to measure 8 inches with that, but they don't. They treat 100 square miles as planar. That's like generally about 100 square miles is, so that would be like a 10 by 10 mile square, for example, is all plane surveying. So I actually make arguments and I talk about ideas around that with plane surveying. So no, I do think plane surveying is effective, and it works with rise over run slope. That's all planar as well. And if the Earth was a sphere within 100 square miles, you would definitely have to incorporate for the curvature. So I don't think all optics are out. No, I think they can be accurate. But if we're talking about something that's going to change the whole paradigm, because the globe has this whole refraction kind of assumption in my viewpoint that they always apply to it. So it's just sort of like an impenetrable, at least for the paradigm, they set up a a good defense system with that. In my
Well,
view.
let's put it this way. As we know, if we take a flat piece of paper and we draw a triangle on it, it doesn't matter how fucked up you make that triangle, as long as the edges are straight, that is, you are going to have interior angles that equal 180 degrees. So, given that our line of sight is literally a line by definition, and if we have a big enough area in which we can have like 3 observers all looking at each other with the ability to take optical angle measurements, if we do that and it turns out that we get more than 180 degrees, which is what would be expected on a curved surface, would that be sufficient? Because we have access to telescopes that can tell you literally the exact azimuth in which you are looking. So if you measure the azimuth between one person yield off into the distance and another person yield off into the distance, and they were to do the same thing to you all the way around that triangle, and when you compared notes, the angles got more than 180 degrees, which would indicate a curve, would that be sufficient for you?
Yeah, so I mean, with spherical excess, this is like another family of optics or another category, because like with plane surveying, you might be doing like much shorter stretches and so on and so forth, and doing backsights and foresights and so on. But with if we're not talking about like longer distance spherical excess measurements from like mountaintops, yeah, that is definitely another category.
Like if we were to go
I
to the
do think
Rockies,
like I mentioned the 4 points and distances, and then you link like a rectangle, and then you link the 4 points on the inside with 2 straight lines, and then all those distances. I know you've seen that, obviously. That's a good way to do distances, but the 3 points is more the spherical excess one. And yeah, I actually have a couple test ideas. One of them involves building physical triangles on the ground and making larger and larger ones, to where you keep measuring physically off the last one. So you make like one small, this has been my idea for years, and I'm just open about it, because if anyone wants to do it, it'd be amazing. I just think it's a great idea, and someday we will do it. But like to have like a triangle that you start with, that you measure as a perfect triangle, and then you actually and then you measure from that first triangle as like the model of it. You then, with very precise tools, you make a larger physical triangle, and then from the next one you make a larger, and you keep doing that, and you do it all with tools, every laser levels, everything you want to use to try to get as perfectly as you can. And eventually, if the Earth was a sphere, like those physical triangles would actually start to deviate, like you said, the angles. It starts to like bow out. So yeah, I do think spherical excess could show one or the other. The optical for mountaintops, though, I do have some concerns with that in terms of refraction. And I do think the realm we're in, like the medium, the ether, and the sky have spherical components, but the ground is planar. So there are spherical effects to refraction.
Well, let me show you this. So here you can see this fucking loser on top of this hill right here. And if I were to spin this 360,
hold on, I'm not in there yet. Hold on, I'm gonna share it on the live stream too, so people can see. So hold on one sec.
All right, let me know when you're ready.
All right. Yep.
Okay, so here you can see this absolute loser with his dog. He's hiking up this little thing. If I were to spin the camera around, a beautiful sight. So I'm seeing here that there's a lot of mountain peaks in which we can choose from. And if we have an individual on this mountain peak way off into the distance and this mountain peak way off into the distance, it seems that we would have a lot of surface area within that triangle. And so if we were to measure the angle of an observer here, and we were to measure the angle of the observer here, and they were to do the exact same thing to the other observers, and he was to do the exact same thing to you and this guy over here, thus getting 3 measurements from each corner of that triangle, and it comes out to more than 180 degrees, given the vast distances involved. Would that be sufficient for you? And if it is, do you want to actually do it? Because I would be willing to fund your trip out to this area. I would let you use my equipment. Of course, we would test it to make sure that the angles are accurate, so there's no funny business going on. I would teach you how to use it and how to get measurements off of it, that kind of thing. And if we were to actually do this, and it turns out that the angles are more than 180 degrees, thus indicating a sphere, would you be comfortable in saying that of the evidence that has been presented to you, it is more likely, at the very least, that the Earth is spherical in nature?
Well, I mean, I would say like I'm aware of basically like probably every argument that's been put forth on the globe, so I'm definitely like fully familiar with this one. And I definitely think that like long range optics and trying to do spherical excess over long distances is problematic. For me, it really would not be definitive or exclusive of the shape of the Earth ultimately, with the optics over that long of a distance. I do think, like I said, there is like a spherical kind of like, just to put it simply, almost like a bending and warping of space-time. I was going to say something else, and then I thought of that. No, but there is like a warping that can affect in the medium of like the direction of light. Obviously, just due to conditions and so on. So, and the way the sky is almost looks like a bubble. It looks like a hemispherical bubble in a way. So, like the way that the sky works, and the medium itself as well, like the medium, like the atmosphere, let's say, and the obviously the way the sky does as well, have those effects. So I think that they're definitely interesting. I mean, we've gone over like the arc of the parallel, like that huge, like multiple thousands of page document. We've gone over that in detail. There's really like no actual measurements in there. They're all like weighted averages. And the other ones I've seen are weighted averages too. I also am aware though of some that claim to be done and are giving the spherical excess effect. Yeah. So I'm aware of those. To me, they're not really conclusive or definitive though, like in terms of tangibly proving that the Earth is actually curving. But I mean, I'm willing to also give like just a good faith, kind of a good faith, like mild concession to say that it potentially is a strong argument for it, because I think it's actually the atmosphere doing it, but then that's extrapolated into an assumption of the ground. But if one is trying to go that route, there are some optics that at times can match a refractive value of what a globe would be.
Well, the way that we would get around that problem is to not only make these measurements multiple times within the same day, but we would also make this measurement over multiple days. So like, let's say if I were to spend even more of my own money and say, okay, not only are we going to make this measurement, we're going to make this measurement 3 times a day for an entire week. Or better yet, we're going to make this measurement 3 times a day for 2 weeks. And we're going to get endless amounts of data out of this shit. We're going to be in data heaven. And after we get all the information, after we collect all the data, we find that not one measurement made on any of the time frames, not on any of the days, not one of it has been less than 180 degrees or right at 180 degrees. All of it has been more than 180 degrees. And we did this over multiple days and multiple times during those days. Yada, 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 you get the idea. Would that
problem is
then be enough?
it would never be enough days. That's the problem, right? If you say you
Well,
do
here-
it for 2 weeks, they'll say, well, why didn't you do it for a month?
All right,
Why
let
didn't you
me
do it for 6
post
months?
this one. Well, no,
Oh,
okay. A few responses to that. First of all, okay, atmospheric conditions. All right, I have 2 images. So the first one, real quick, I just want to say this: there is a phenomenon that some atmospherical conditions, they seem very consistent within a certain area, like more frequently than other areas. Some areas change a lot. So for example, just real quick, I'm going to post 2 images in the chat. This one in the live stream text. This one shows like the Blackpool Tower and the mountains behind it. This one seems to be pretty consistent, that it often is like this. That's why, like, this is the whole Ranty thing, when Ranty like claimed that he flipped or whatever. You were, I know, around then, and what was going on these Discord servers was wild back then and all that. But this was like the picture that flipped him or whatever, the one I just posted. Because basically the mountain, in a nutshell, the mountains behind the snow mountains, the fact that they're appearing lower than Blackpool Tower doesn't fit planar trig. So they claim that, oh, and it close, within a range fits what would be the globe, like if it was curving around. But here's the issue: this is not the case all over the Earth. Like the curve, the claimed like, oh, that's lower, therefore it's the globe. Because there's the one that Zanuck always brings in too, with the mountains that are smaller in the distance, and he's trying to claim it's links to the Earth curve. But there's many other observations where it doesn't match, where meaning that the White Mountains would actually match the planar trig. So that's one of the issues with that. And the thing is, in certain areas, it's more consistent that the effect can be had, like if there is a warping effect, whereas other areas, it changes a lot. Like there's other places where, like that mountain and the Blackpool Tower would change dramatically on different days, different weeks, but other places it's more stable. So
Okay.
anyways, that brings some of those points up in terms of like the repeated ones. But but of course, repeated is good. And then there was a whole second part, but I'll let you respond.
Let me try to answer that then. Okay, new plan then. Let's adjust our plan. Let's say I were to spend even more of my own money, and instead of just going to the Colorado mountains and staying there for a week and making 3 measurements a day, we do that twice once in Colorado, and once in, like, I don't know, North Carolina with the Appalachian Mountains. So we find three peaks of about the same distance apart as what we were doing in Colorado. The Appalachian Mountains are fucking massive and vast, and there's plenty of peaks to choose from. And we were to do the same thing over there on the other side of the country, which would be stay there for a week, make 3 measurements a day, collect the data, that kind of thing. And if both locations, after everything is said and done, both locations show a consistent value over 180 degrees, at that point, would it then be sufficient enough for you to say that it's more likely that the Earth is a sphere?
I'm sorry, dude. Could you repeat that? Or just I did hear it, but then I think I missed part of it. Sorry.
Okay. So what part? I'll just say the whole thing. Okay. So we will adjust our plans. So what if we did this observation in Colorado, and then I were to spend even more of my own money and then fly you out to the Appalachian Mountains, which is on the east coast of the United States. And so we would be in the Rockies or Colorado or wherever the fuck for 1 week, and we would be making 3 measurements a day to completely have a nice mix of atmospheric conditions over that week. And then we would do the exact same thing, but with the Appalachian Mountains, which is on the east coast of the United States. We would stay there for a week, get 3 measurements a day, blah, blah, blah. You get the idea. If it turns out that after everything is said and done, we don't find a single instance where the angles were less than 180 degrees, would you then say it was sufficient to show that the Earth is round?
Well, the thing is, not necessarily, because you're getting to like the extents of how far you can see at that point. If you're trying to point it like as far as you can, I mean, how many miles are you talking between the? By the way, let me post this real quick here, just in the chat. Okay, this one here, I was looking for this image, which is partially why I didn't follow fully what you were saying about the different locations, but I hear what you're saying though. Let me just, okay, I posted this real quick. This is basically the claim, and it's more or less the claim you're making. This is an image I saved. It's a good one because somebody, I think, I don't know if Ruhif made this. Maybe he did, actually. It kind of looks like a Ruhif thing here. But really, he just pulled this from this 1927 datum triangulation in Utah. And if you look at the website there, .gov, all that, obviously. But this is like an official, like this is called the triangulation in Utah. So like the arc of the parallel is the one that we've gone through, and we've gone through all these, but this is another one. This is later because the arc of the parallel is earlier. This one's 1927 is claimed. So yeah, these angles right here, like, I mean, Jeremy often says that there's like no actual measurements, but this is claimed to be, well, actually, I'd have to double check if this one's also weighted averages, the triangulation in Utah. Does anyone know offhand whether, but anyways, this little GIF here shows like what was claimed to be measured, and these don't, yeah, I guess I would have to double check if this one's weighted averages as well. But nonetheless, this is the claim, right? I mean, this is essentially what you're claiming.
Well, it's not. Well, I'm not making a claim. What I'm proposing is an observation and a hypothetical. So on the hypothetical that we do this, on the hypothetical that you have the equipment and you trust the equipment, and we get the values and they end up being more than 180 degrees every single time we do it. And we did it in the Rockies, we did it in the Appalachian Mountains, 2 different sides of the country over a week, 3 measurements a day, that kind of thing, really, really dialing it in and making sure that we weren't dealing with atmospheric fuckery in any way, shape, or form. Would that be enough for you? And based on what I'm hearing, it's like, not really. Even if we did all of this, and even if I spent the money, flew you out there, and we did the measurements, and the data was, to any reasonable person, pretty fucking conclusive, it just wouldn't be enough for you. That's what I'm hearing.
Well, the thing is, we're talking about optics from like mountaintops over very long distances. So this is a particular phenomenon. Like some of these other optics we're talking about, like plane surveying or something that's shorter distance, or maybe other like laser tests. There's all kinds of other things, but this particular one, if we're talking these long range distances, like I think doing the spherical excess triangle is a really good test. The way I've thought about it is that we would have to set up like, on land that you own ideally, a massive triangle basically. Then between those 3 points on that land, you could do a bunch of tests. You could do optical ones. You could try to measure the physical distance on the ground. You could even like build like a moat of water. And then you could also link that with like curvature of water tests. You use like lasers. I've had all these ideas of how to do it. But nonetheless, you have 3 points and you can do a bunch of things. You can use laser rangefinders, use LiDAR. You can do drones, like different tests with drones. You can do optics and so on. to, you know, and have one massive triangle. And then that also could be like a monument type site that people could come visit and actually see and confirm things themselves as well, and like see the test done. So anyways, I think the whole triangle thing is it can be a very good way to establish the shape of the Earth. But this one where you're like only doing optics from high altitude or somewhat higher altitude over very long distances, I do think is problematic, because there are these like dropping and raising effects that happen. So like, for example, this image I'm posting right now in the chat, that it says atmospheric magnification, the one I just posted. Now, I'm not really referring to this as being like the atmospheric magnification part, but nonetheless, it's the same location, same elevation, but just different days. And see how that the oil rigs are obviously at different distances, but the picture on the right, the oil rig is like almost equal with the like height wise with the one on the left. But the picture on the left, the oil rig is way sunken down. So like if something is sunken down like that further, like we're talking about, which is essentially what the spherical excess optically from high mountain types over long distances is a dropping effect. And so the fact that just on different days we see this on the ground level happening dramatically indicates that that's not necessarily a way to isolate the curvature of the Earth just based on that alone, of that drop effect. There would need to be more incorporated to understand what is actually occurring there. If it can be flat on one day and curved on another, basically, you know, that's strange. Whereas like that Blackpool Tower one is pretty consistent. It doesn't move around, even though the mountains are behind the tower. And in this case, one oil rig's behind another. So yeah, so if you see what I mean, if you're doing like optical, long range with spherical excess and trying to have that be definitive, if that dropping effect's happening, one could interpret that as that the ground is curving, but it actually would just be these optics that we know happen.
Well, we wouldn't be measuring the altitude. We would only be measuring the azimuth. So whether the mountain is higher or lower in your optical train, that actually wouldn't matter when it comes to the azimuth measurement, since that would be the only thing that we would actually care about, not the altitude. So let's imagine you're pointed at a particular object at a particular azimuth, and you had to raise the telescope up in order to see that object again. The azimuth would not change. The altitude would change, but the azimuth wouldn't. So
no, I know, and I know that's what it is. I mean, it's an optical drop effect, but it ends up resulting in an azimuth distance that's larger than 180.
An azimuth would be left
a
and right.
horizontal angle. I know it's a horizontal angle, but the drop effect is ultimately what's causing it.
No. A drop would be up and down. If we were dealing with just the azimuth measurements, that would be left and right. And the way that we would isolate and making sure that there's no fuckery is that we would be making the measurements multiple times a day. And to make sure that the location wasn't the one fucking up, we would go literally to the other side of the country and do it again. In fact, I could spend even more of my own money, and we can go all the way to Canada. Canada's got a fuck ton of mountains up there. So we can go to the deserts of Nevada. We can go to the lush forests of the Appalachian Mountains. We can go to the wintry wasteland that is Canada. We can do this in 2 different countries and multiple different climates and multiple different areas and that kind of thing. But let's hypothetically say I did all that and I paid for all of those plane tickets and really hurt my bank account in the process. And no matter what we did, we just couldn't get the goddamn angles to be 180 degrees or less. They were always over 180 degrees. Damn it. Would it then, at that point in time, be enough for you to say that, yes, we now have evidence to show that the Earth is round? And let me just cut to the chase.
So
I'm trying to ask you, what would it take? How many of these measurements would I have to plan and trip for, and we would have to go to, and what conditions, how many conditions, like when is it enough, or is it ever going to be enough?
I can tell you. If Geo said there's atmospheric magnification happening, that would make the thing look bigger and the angle would be bigger. None of this is tangible. You need something tangible to show that that's what's happening. This optical shit is for the birds.
Yeah,
So
you
They're
can't
not
do
interested in buying a globe, Brad. They're not interested in buying a globe, bro.
Don't
No,
talk
I
about
think the
shit with
optics
Daddy
the
that way.
optics are still cool and useful, because Rez, I think like what actually does occur is like in that image I posted earlier. I'm just gonna post it one more time right here. Okay, I just posted it again. So it's like these objects can rise and fall, and then the thing is that is linked to spherical excess in terms of like this right here, this image, which you may have seen this, but it just shows how the azimuth angle is different based on basically, that drop or non-drop effect. So I do think it's related to drop, although I do understand what you're saying about that it is a horizontal angle as well. and that could be broken apart. But I guess like to answer your ultimate question though, I mean, we can continue on this, but because you have been like, I would say that to me, I don't think this is definitive because the angles that, from my understanding, when this is done, is that they really vary. Sometimes they're a little more than 180, sometimes they're less, sometimes they're more, sometimes they're less. That's why like the arc of the parallel, they did this massive like averaging, but they never actually gave the independent measurements. Some of these other ones, like, you know, may claim or list more that they claim were direct measurements. We'd have to like find that deeper. I don't know. I was going to double check that triangulation in Utah one, but I mean, I think when Jeremy says that, I don't think that's really been defeated yet, that there isn't really any singular measurement of spherical excess. It's all like averages and so on, because these effects
Even
I'm
if they
showing,
did,
well, this lastly, these effects I'm showing with the oil rigs up and down, mountains and all the mountains up and down. My point is that those positions change. We know those change even on a day-to-day basis. So to try to determine like a shape of an Earth linked to that, anything related to that effect could be problematic. But yeah, go ahead.
Can I
Yeah,
respond to the,
but it's okay when you guys use the we see too far observations. Oh, but those are okay, right? When it comes to optics.
Well, I would say those are different because one of them is a position change, which can happen. We know like in water, like you can, like the fish can look like it's over there, even though it's over there. Like we know that like displacement, but the curvature affecting, you guys are more requesting in some way that the Earth has to like sometimes have like a curve that matches a globe. And then other times it's like extended out, like a magic carpet that just extends out like an extended plane. So that's not really the same as just changing position. You're actually showing more land that shouldn't even be visible.
So what would it look
can I
like if it was curved, Geo?
can I just
I'm sorry.
reply to
Oh, my
the
bad.
image that you sent, Geo? Because it's the image that you showed in the live chat where it has the so you have the red angle, then you have the green angle, and how angle A is larger than angle B. Well, the only way that angle B would show up as larger with our telescope equipment is to literally change the pivot of the azimuth angle. We're not going to be doing that at all. So if you look at the red angle, the represented by the red band, let's call it, that would be like our azimuth being at level. But then the green, we would have to literally tip the entire tripod that is affixed to the telescope mount in order to get that to change. We won't be doing that. Everything would be
But that's what's claimed
consistent every single time. So if we did that and we got angles that were actually more than 180 degrees, then would it be enough for you? I think I got the answer to this question. It seems like even though it would be valid and sound and logical, mathematically consistent, all that good shit, it still wouldn't be enough for you. So I could not take you to enough
Nobody ever
locations.
said it was sound.
Yeah, I know. I didn't say a lot
Yeah.
of that, but that's okay. I mean, I'm not saying you're trying to bad faith represent me, but it's just maybe not quite what I would say. But let me jump in. So I wanted to try to jump in quickly before to say that, okay, I know you're not tilting necessarily like the telescope or anything like that
The
from
azimuth.
level. Yeah, well, the actual like vertical tilt of it. But the thing is that between the red and the green in that image, but the claim is on the globe Earth that you are actually tilted back from it in a way where your orientation is not all coplanar. Your orientation is actually tilted because you're 80 miles, 50 miles, whatever the distance is. That there is actually a very slight, tilt of level basically compared to the other point, to where you get this effect. So, I mean, dude, what I'm saying is that it happens, and then lastly, like, well, it happens in different. Like I'm explaining with like
some point in time be willing to accept that, you know what, we've made this measurement on multiple different days, in multiple different locations, all over the countries, hell, even in multiple countries. We went from the deserts of Arizona to the lush rainforests of the Appalachians. We went to the wintry hellhole of Canada. We've done this so many
single,
different
sir?
ways.
Are you single and ready to
And
mingle?
so when
well, hold on,
all
bro,
of
but
this,
no,
I'm sorry,
okay. I think doing all these is not a bad idea. Like, I think it's always good to do things. What I'm saying is my understanding is that they vary from a little more than 180 to some that are less. And then that's where you get into like either weighted averages and refraction effects. In terms of going to different places, I totally agree with you that it's very important to go to multiple places on Earth. Like, even if we show a curvature test or just any of these things, they all need to be tested on multiple places. You can't just take, I mean, technically, could you have just one flat area and the whole rest is curved? Under some wild concept, maybe, I guess you could have some actual flat area on a globe, but it couldn't be too big, but you could have some. But so yeah, either way though, this all needs to be done in multiple areas. So I agree with that. In terms of optical observations of mountains, well, that's what I was getting into too. Some areas are very consistently one way, like kind of distorted one way or another, and then some vary quite a bit. So I mean, if you're asking me if like going to 3 or 4 or even 5 locations from high mountaintops around the Earth, doing spherical excess with optics like this, or I mean, doing the spherical measurements like this, and if I was getting all more than 180 and I saw all of that from multiple positions, obviously that would be strong evidence to the phenomenon of observing that. What does it
If
mean
there's
would be another question. But if that could be replicated to because right now there's not, like we've talked about, there's really no actual measurements of it. It's all weighted averages.
let me get in real quick.
Go ahead.
If things are getting magnified even slightly in the distance though, and you go to measure an angle between left to right and it's magnified, obviously it's going to be bigger than it actually is. So the bullshit spherical triangles don't really mean anything because you don't know where the light's actually going. You don't have any measurements of where the light's going. Like you
What do you
just
mean
see light.
magnified?
You just see light, and that's all you know is that this is the angle the light entered your tool at. Like you don't know what path the light took or any of that. You've never measured it or anything.
So everything would be just okay. So the light always takes the path, regardless of the conditions, regardless of the location, to fool us into thinking that the Earth is round consistently, without fail, regardless of the conditions. Okay, I got a bridge to sell you.
I don't think you're
I
even
definitely
getting
didn't say that.
the
Hold on, bro.
no.
You're
No,
a
because it
straw
varies.
man and son. Hello? You're just a straw man and son of a bitch, aren't you? I never said that. I said that if things are getting magnified, obviously the angle is going to be more than 180. And they also measured angles less than 180 when they did the spherical excess measurement. So take
Cool.
that.
Then we should see it ourselves, shouldn't we? So let's do it.
See what?
So that's why I was asking if this would be enough. Obviously, the answer is no. We could have just had this conversation in 30 seconds by saying, you know what, Reds, I'm not even going to waste your time. Even if you took me to a bajillion different mountaintops and we took a bajillion different measurements, it wouldn't be satisfactory to me. That's all that needed to be said. Holy shit.
Yeah, that's what
That was,
was said to you
that was
multiple
Jeremy's.
times.
I led with that.
Okay,
The
so
Only
first thing
argument-
said to
we
you,
don't know.
Reds. This is so
at the end of
dishonest.
So at the end of the day, Geo, I'm assuming you're okay with them speaking for you. So at the end of the day, Geo, none of this would ever be sufficient for you.
No, I was
Is-
trying
He told you what
to
it
make
proves,
a joke and
dude.
say that was Jeremy's Joe Pesci impression.
Nothing is
Okay.
ever good enough.
That's what I was thinking of. I was trying to think of the actor. Sorry, my mind was in joke mode. No, dude, Jeremy. Well, I don't know. I guess he thought he's strong, but we can. It's all good.
All right.
What?
Jeremy thinks that nobody knows which way light's bending for some reason.
Yeah,
That's his
Jeremy's
only
making an
argument.
argument saying that even though you have like those optical observations, if you haven't actually measured the way the light's bending, then it's assumptions, and therefore it's not useful.
That's
But
why
know
we
which
try
way
to
light's
eliminate.
bending.
Well, okay. The way that light typically bends in atmosphere is with atmospheric conditions. We know
I'm going
this.
next.
That's why what we try to do is we try to eliminate that as a variable to the best of our abilities. So how do we get rid of that noise in the data? The way we do it in any other situation is we just get more data. We do this over and over and over and over again. Well, maybe this particular location is really fucked for some reason. Maybe there's
So
always
the data proves the data.
Hold
The
on, man.
data
I'm
proves
going
the
next, bro.
data.
I called it, dude. I called next after Red's done with his
Yeah,
monologue. Go ahead,
obviously
Red.
these guys are in this. Let's obviously let them go. I was trying to.
No, that's fine. It's fine. My conversation was
better
with you, and I think I got what I needed. So I'll just stop here.
No, dude, finish your point. Jeremy just wanted to respond. If you're asking me if these long distance, I have responded in. Well, okay. Jeremy was responding though, or he wanted to go next. Do you want to finish your point though?
It's fine. It's fine. I'm good here. I think I got my answer. I'm fine.
All right.
Yeah,
Well,
all
but if
Jeremy
you're gonna go to that, then at least let me respond. Okay. I would say, in my viewpoint, I don't think that long distance spherical excess observations from mountaintops is sufficient to be definitive for the shape of the Earth. Reasons being, yes, the refractive effects, the fact that it changes quite a bit. However, I also said if we went out to multiple places ourselves, we went to 3 sites, 4 sites, 5, 6, different continents, different parts of the world, different times a year, and we were always getting that effect. Like I said, that would be strong evidence that effect is a common occurrence. But what is the cause of it would be the next question. And that's why I think when Jeremy brought in the actual path of the light, that's what would actually need to be physically measured to delineate between shape of Earth and the path of the light that you're seeing when we're talking about optics like this. So that's the issue with it. Meaning that even if we showed for sure that it was always more than 180, even if we showed that, there's now two options. It's an optical effect in the medium, or it has to do with the shape of the Earth, or that the ground's curving, if that's the claim that the globe would be making. So that's why Jeremy, I think his point of saying like actually having to know which way the light is actually
built
traveling
a model of that particular area. So if the angles were consistent, then that means that we can go to that peak, and before we measure any angles, all we have to do is tell the telescope, hey, point to this peak, which, if our measurements are correct, should be this many degrees away. So if light was traveling in a straight line, that means the angles were consistent. That means that the telescope now has predictive capabilities within its electric motors that can measure angles very accurately. So if we go to a different peak and I say, okay, go ahead and point to the observer that's at that mountaintop, and it does it, and then I call you on the phone and I say, okay, I'm slewing the telescope to point at you based on our prediction of where it should be if light was going straight, and it does, and you see the laser pointed right at your eyeball, that would prove a few things. One, it would prove that our initial measurements were correct, and it would prove that light is traveling so consistently that it was able to make a prediction and hit you square in the eyeball based on that prediction. See what I mean?
Okay, no, that's not a rebuttal at all to what I said.
Okay.
I don't know what you're going to do with your telescope, whatever, at the top of the mountain. But if you point it at a place and you're saying this is the spot the thing is in, and it's a straight line because I can predict it, that's fucking worthless. That doesn't mean that's what it is just because you can predict it. If it's a consistent effect, of course you could predict it because it's a consistent effect.
So light would always be curving to the left, regardless if I do it from the north or the south?
If there's magnification happening, light would always be, that angle would always be bigger because it's magnified.
You're not understanding. Okay, if I am dealing with an optical effect, and let's say that I'm looking directly north and south. If I'm looking from south to north, if we assume that the light is curving to the left, and that must mean from south to north, the light would be curving to the right, vice versa, that kind of thing.
I never said this is not any part of my argument at all, or anything to do with
obviously
anything
it's
I said.
not,
So
because
I have no idea what you're even talking about right now.
It's a rebuttal. He's doing a rebuttal.
Dude, obviously it wasn't part of your argument, because if it was part of your argument, you wouldn't have said the horse shit that you did. I'm rebuttaling.
This has nothing to do with anything I said.
Actually, it
So
does.
This is not a
Actually,
rebuttal.
it does.
No,
You said that the light could be haphazardly going left or right or whatever the fuck. We can test that. Actually,
I didn't say that. I didn't say that. Actually, I said if things are getting magnified in the distance, obviously the angle would be bigger than 180 because it's bigger. It's optically bigger.
Magnification doesn't matter when we're dealing with a target.
So you're looking out optically, and you're doing a left to right measurement. It's going to be bigger because it's getting magnified. Duh.
Okay, I cannot believe I have to break out the fucking crayons here. All right, I'm about to screen share something. Let's go ahead and do this. Okay.
Wait, left and right of what? North? Because isn't that a circle?
Hang on.
Yeah, I'm trying to. It's all good. We can just go through it one at a time. I'm trying to understand. What you made me think of, like a preferred direction of light and getting into like whether there's a clockwise, counterclockwise.
No, hang on. Geo, I'm gonna ask you a question here, and I'm screen sharing. If you can share my screen share.
Okay. Yeah. 1 second. You got to throw Coriolis in there. So, all right, go ahead.
Cool. All right, cool.
No, it's a Texas sharpshooter fallacy.
All right, so let's go ahead and look at this target. Okay, so right now, let me ask you a quick question. Geo, I know what the answer is, but I'm going to ask you just to physically do it. Can you identify the center of this target?
Let's say where the two black lines meet.
Okay, cool. So it's right here. So now what I'm going to do is I'm going to magnify it. Can you identify the center of this target?
Yep.
Go from the left side of the circle. Go all the way to the left side of the circle, and then go all the way to the right side of the circle.
Not done yet.
Then magnify it.
Not done yet.
Okay.
So,
because by the way, I'm just giving general answers.
This doesn't have to do with anything I'm talking about. So,
oh, for fuck's sake.
All right, but let's at least let him go through it because he's wanting to, and then oh wait, you turned it off. What were you gonna?
Well, Jeremy keeps interrupting. I can't get a fucking word out.
You stopped talking, dude. I jumped in to say this doesn't have anything to do with what I was
waiting for Geo to respond. Weren't you the one talking about the rules of, hey, let's not try to talk over each other, and you're breaking your own rules?
I wasn't talking over anyone. I jumped in between you guys because I was trying to say something. It's not a break. I didn't break shit.
Yeah, you did.
It is Jeremy. It is Jeremy's argument.
I think Jeremy just said it didn't have to do with his argument. Maybe he wanted a rebuttal to his argument.
Yeah, they have
was
no
this your?
rebuttal to the thing I'm saying.
Well, hold
So
on. Was this your rebuttal? He did kind of interrupt you though, but is this your rebuttal to Jeremy, or is this a new thing? Let's just get
It's
that
a
clear.
rebuttal to the concept that Jeremy was talking about, and I wanted to get an outside perspective, which is why I started talking to you.
Okay, then
So,
can you share it, Jeremy? Can you oblige us and him going through that then, if this is his response? I want at
yeah,
least to
that's
see what
fine. I'll
the end of
jump
the
in
argument
after
was.
and show you why this has nothing to do with what I'm talking about. Go ahead.
You're talking about measuring the path of light in the physical world geometrically.
yeah, so I believe the argument was that magnification is somehow going to fuck up the path of light. Okay, let's assume for the sake of argument that that's true. That would mean that the mere fact that it gets fucked up means we cannot make any accurate or reliable predictions. So
Well,
we
well,
would
here's
That's straw man. I don't know. I'm gonna go on mute or fucking something because I
no, dude.
can't
We
even
can.
listen.
It's
This
all
is
good.
just
We can.
straw man after straw man.
All right. Well, hold on, Reg. Maybe you weren't fully finished.
at this
Let's just
point, I'm done. I'm done. It's like if I try to do a rebuttal, it's just going to be, oh, he's strawman me. No, the fuck I'm not. You just don't like the fact that your bullshit's being called out.
You're done.
Well,
Like, holy shit. Because there are consequences to what Jeremy said. There are consequences to that. And those consequences can be empirically tested. And if I go out and I say, okay, if his consequences were true, if what he's saying was true, then I wouldn't be able to do this one thing. And if I'm able to do that thing, then that means his consequences weren't exactly influencing the original data point, because his consequences would corrode the accuracy of those exact same data points. How is this hard to figure out?
well, let me. Okay, he dropped out. He might have been like stressed out at work or something right now. So let's just give him a break. He's got a lot going on probably. So, but he did drop out because he's a good guy, but he was getting a little heated. It's all good. So, atmospheric matter. Okay, this one I just posted here. This is again that same So, what do you think is happening here? Because I think generally what Jeremy would have been kind of was in my mind referring to, or at least I'll continue it at least. Is that in like these two images right here, where one of them the water is like covering, like on the left the water is like covering the bottom of the legs of the oil rig on the left, and it's covering quite a bit of the one on the right. The one on the right is way lower. On the other one, the oil rigs are about the same, and you seem to see the horizon is like beyond the second oil rig. So like the reason I bring this up, this does say atmospheric magnification on it, this little image, but obviously like that's an interpretation that somebody put on there. It could be debated what this is, but I think like if we're talking about that type of effect and it changing the physical position, then I think that's maybe what Jeremy is linking to, that the path of light, is changing, or that's maybe even the argument I'm kind of adding in there. So I guess my question is like, what do you think of that? And then what do you think is happening in those two pictures? If it's not magnification, and then obviously one of those, like the one on the right pretty much looks like a flat earth. The one on the left could be interpreted as a globe because it's lower down, and somebody could think, oh, that's the tip of the ball right there where the water is. And then the one on the oil rig is lower, which would almost be like the idea of dropping over a curve. But then the other one looks flat and it's all flush and level. So,
Yeah,
like,
but
what do
we're
you think
talking
is going
about
on there? Because it's linked to the magnification, and then ultimately the spherical excess or the path of light when it comes to like, these optical measurements and so on.
Well, again, we're talking about azimuths. Okay, so what we would expect to see if the rebuttal that Jeremy was giving was accurate? We would expect that platform to go from the right side of the front one to the left side of the front one. That's not happening. That platform is always going to be on the left side, i.e. the azimuths are going to be exactly the same. Now, let's say, for the sake of argument, that maybe there's some sideways refraction. Refraction decided that it was getting a bit Tokyo drifty on that particular day. Well, that's when we go ahead and we do more observations. That way we can clear out the noise in the data. So we do this over and over and over and over again. We do this for a week, 3 times a day, morning, noon, night. We do that to make sure that we have a nice spread. And if we did this only once, you would have reason to doubt. You would have absolutely reason to doubt. But if we did this multiple times a day, in multiple different locations, probably over multiple times throughout the year, and we always get consistent results, we cannot say that side-to-side refraction is such, especially since we're doing it in multiple different directions, hence the triangle. Because one observer would be looking, let's say, I'm just going to pull a direction out of my ass, due north. Then a second observer would be looking the opposite of that. Then the third would be at an angle to those two. So we would have a nice spread of multiple different directions. And then we could switch it up. Okay, for this particular day, you go to this peak, you go to this peak, you go to this peak. We can switch the instruments around, thus making the data even cleaner still. We do all these things to try and make sure that the data that we're getting is clean of any noise. Because what you're worried about is, how do we eliminate noise to the point that any reasonable person would say that the data is clean? That's why I'm suggesting we do it in the way that we do it. But you're telling me that even if we do it in that way, you would still not be comfortable saying that that was enough.
You know, that's because that's the criterion problem, right? They use the data to prove the data.
Fuck's sake. I don't even know.
Do you know what the criterion problem is?
I know I wasn't talking to you.
That's true. How do
So,
you know that?
Gio, would you please respond to what I just said, or did that throw off your train of thought?
No, it's all good. I'm listening. I heard everything. I mean, if you want to talk with Tor about that, that's fine too. Either way, but okay, my response though to what you said would be this. So I'm gonna post this just one more time. I'm not trying to spam it, just so it's kind of in the feed since I'm referencing it. So like the oil rig on the right picture is like skinny, and the oil rig on the left is like fattened. It's like literally fatter. It's like wider. So that would throw off the azimuth right there. And if you want to call that sideways refraction, I guess we could, but I mean, it's like a bowing out effect. Like the actual width is actually different, like significantly, in terms of the pixels. Now this is claimed to be the same location, same elevation, but just different days. Obviously, it'd be good to always get, triple, quadruple checking of all these kinds of things. But I mean, there's a lot of other things like this. Now, the only reason I go back to this to respond is because I hear what you're saying. The thing is that, and that's why when Jeremy was mentioning like the path of light, I agree with him in that way, is that's obviously going to change and the only reason I'm going to this, like, I realize this is a different thing. This is low elevation down to the water observations over like a few miles, whereas what you're talking about is more like spherical excess from mountaintops. These are obviously different. There's different arguments for them too. Like some will claim that there's not the refraction at the high altitude, like people like Ruhif and others and so on, that's that there's much less to deal with and so on, versus on the ground, which I don't mention Ruhif for any specific reason. He popped in my mind. I'm not trying to quote him or anything in any particular way. But yeah, so like these observational effects, at high altitude versus low altitude are different. My only reason to go to the low altitude is just to show the dramatic nature of it, and that the azimuth and zenith, like all of the angles are essentially can be skewed to a degree. And so that's where like the idea of the path of light, because if you have like the physical ground, like the ground is not changing, like unless anyone thinks like the ground is actually morphing. If we're staying in reality in that way, like the ground is there, it's there no matter what, but it's the medium. And if like on that image of the atmospheric magnification, like which one's true? Like is the level of the two matches the one on the left or the right? And then which is the true like curvature of the earth? Is it the one on the left or the right? You see what I mean? So that's why that image is so interesting, and it just brings in some of these optical effects. And I only bring that in ultimately to give you some thoughts, or give you some of my thoughts about why I think some these may not be definitive in terms of.
I understand that, and
Can I say something, Red? Can I say something, Red?
Well, that wasn't a response to him though. Can we let him respond?
But I mean, it's directly to this point, and it may lend to the conversation. If you're at observation, you're at point A, and you're looking at a mountaintop B and a mountaintop C. If you know the distance from B to C, you can predict what that angle should be straight up geometrically, and you measure it and see what you actually get, and that would probably confirm whether or not you've got any kind of magnification or distortion going on.
Yeah, and so to your point, Gio, you're like, okay, so which is the correct one, the left one or the right one or the top one or the bottom one, that kind of thing. I hear you. That's why I suggested we do this multiple times to make sure that the data we get is clean at the end of our analysis. Because if you were to only do this one day, we don't even know how much noise is in the data. We don't know how reliable it is. We don't know the quality of the data. And that's why we would need to do this over multiple different days, possibly even multiple different locations, possibly in multiple different countries. And if I was a very rich and generous person, I would be willing to pay so that we could travel to all of these extravagant locations with 5-star accommodations, of course, and do all of these measurements. And that way, at the end of the day, we gather all of this effort together in one spot and we analyze the data, and we know that because we did it over multiple different days, multiple times a day, multiple different locations, different times of year, yada, 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 blah, 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 we have filtered out enough noise to the point where the results would be conclusive. It would be satisfactory to you. And this all came down to a personal thing. And I was asking you a personal question. When would it be satisfactory? If the answer is never, no matter how many times we do this, and you would prefer it be done in a different way or whatever, that's fine, I guess. I don't agree with you, but that would be your position on it. But if your position is, hey, I appreciate all this effort and I believe it would be valuable in terms of just having a conversation about it, but in terms of actually turning me to the dark side, so to speak, it would not be enough, okay, then it just wouldn't be enough. In which case, this would be wasted. This would all be a wasted effort, because if the whole idea is to turn you, for lack of a better term, this would not be the way to do that task.
Well, okay, so everybody else can give their comments too, obviously, so, you know, if anyone else has thoughts on it too, because what we're basically talking about is like spherical excess measurements using, you know, telescopes or theodolites or, you know, long distance on mountaintops, and then getting these larger, like once you get 3 points that are far enough apart, the claim is that the angle starts to be larger than 180 degrees, you know, in total. And the further the distance, the more spherical excess would be the case. So like 3 angles of a triangle always match up to 180. And the claim is that, you know, if you have like 3 points define a plane, so a triangle defines a plane, like any 3 points define a plane. And so once you have 3 points, you can have a plane, and then that plane is would match to a planar Earth, and it would always just be 180. But on a globe, like it would start to kind of bow out basically as those 3 points are on a ball, and then you get more than 180. So now, if that's what we're talking about, I would say in terms of like something being very, like for me, definitive, if we had the physical triangle one where we build physical triangles on the ground and that showed it, that would be compelling. Meaning, if like, okay, you get a small triangle, larger, 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 keep making larger ones. Now you're going to have some margin of error, obviously, like in making the larger triangle, of course. But if you started to get a consistent effect, like once the triangle were X distance away, and then the next bigger one, and it actually matched the curvature of the claimed globe, that would be getting pretty close to what could be definitive. Because now we're talking about something tangible, physical, on the ground, the margin of error is incorporated. And if you actually got it with a physical, tangible structure, that would be very strong. The optics are always going to probably be debated. Yeah. And for a lot of people, it may not be definitive to like what you're talking about, like flip someone or turn them or whatever, like on their view of the shape of the earth and so on. You know, the optics seem to like strengthen people's arguments, but how often do they really shift someone fully? Because yeah, when you're dealing with like an optical spherical excess, I mean, if we went all around the world and we measured that ourselves, like you were saying, with tons of data points and the averages really were showing it, like I said earlier, I mean, that would be compelling evidence that that effect is occurring. But then the question is, what is the cause of that effect? Is it because the ground's curving, or is it because the medium has a refractive effect? Would have to then be the next question. So in terms of like changing someone's view of the shape of the earth, wouldn't it have to go to that step before it could really be deciphered either way?
No, because we would have answered that question within the steps themselves. As I said, we eliminate that as a possibility, because if it was really the atmosphere, well, we say, okay, if the atmosphere was wonky on this particular day, we'll do it in multiple different days. Well, if the atmosphere was wonky of that particular location, then we'll go into an entirely different location. And if the atmosphere was wonky during this particular time of year, then we'll do the observation at a different type of year. If we wanted to go to Colorado in the summer, and then go to Colorado in the winter, and then do it, and then go to Appalachian in the summer, and then go to Appalachian in the winter, and then go to Canada in the summer and in the winter, and blah, blah, blah. You get the idea. We basically can mix and match this 6 ways to Sunday until we're fucking sick of it. We're tired of airplane food, my guy. We are tired of getting molested by TSA, but we go through all that process. Even though we did everything in our power to make sure that the data is clean, and when all is said and done, just the mere fact it's an optical thing is the big hang up for you. So when you say that the physical structure would be nice, the optics will never be.
Well, first of all, we'll be on a private jet, so we'll be
I don't know if I have that much money.
We'll be able to bypass the TSA, but to fly all over to do spherical excess measurements. Well, okay, so I mean, you're really trying to like pin me. That's fine though. You're trying to like pin me down on how compelling it would be and so on, or whether optics would ever be. Well, for example, let me say this real quick. What if
Left lane's gonna fly
what
us.
if there's an optical effect? What if there's like a lens effect to the environment, to the atmosphere, etc. Whereas
That-
when you get far apart, there's like a warping effect because you're getting to like the extent of how far you can see. Essentially, I'm not trying to put that forth as like a rebuttal or as a theory right now. I'm just saying if something like that was the case, I would be concerned that if I took, even if we had like, I'm trying to like give you like that. Let's say we went to all those sites and we really did find that, like, that if we're at a closer 3 points, we just get 180, 180, 180. But once you go a little further 3 points, a little further, all of a sudden you're getting 180.1. Interesting. Then you start getting 180.2, 180.3. Like optically, that obviously would be compelling. I mean, that wouldn't be random. It's not just some random effect like you were saying, like some wonky, just like some wind blew through. Like if you're
Yeah,
getting a
but-
consistent effect like that, yeah, obviously that would have to be considered. And if it's accurate, if it's measured like that, to where then you get 180.4, 180.5, as you keep moving those 3 points further and further apart, it would obviously show that an effect is occurring that is matching that effect. I mean, if you're really able to measure it to that. So I mean,
Yeah,
I wouldn't like deny that data if it was if I was, especially hypothetically primarily involved in it and doing it myself and so on.
Well, I was
I'm not
gonna
aware of
say-
that data existing, but yeah, go ahead.
Well, that's why we would get it ourselves. So the reason why I wanted to really harp on the lensing thing is that I said it can be tested. Now, I mentioned one way, and that was with the left and right thing, but let's ignore that for now. Lensing would require some sort of change to the apparent size of whatever mountaintop we happen to be looking at. Now, I'm going to assume, for the sake of argument, that we agree that topographical maps are accurate, at least good enough for our purposes, good enough so that hikers know where a particular rock is or where a particular summit is and that kind of thing, which means we have angular sizes to work with. If the angular size stays as it should be within our optics, then that would mean that lensing is not occurring. Lensing would impact the angular size explicitly. So if we're at all three mountaintops, I get, okay, I'm going to measure the angles to these other two observers, and they're going to do the exact same thing from their locations with their telescopes. Okay, they do that. Now I'm going to make a second measurement. I'm going to measure the angular size of a particular landmark. Oh, so on this side of the mountain, there's this little ridge. On this side of the mountain, there's this little boulder, and I can see it within my optics. I can then compare that to the measurements of topographical maps and do some trig. Okay, if there was no lensing effect whatsoever, it should be this angular size, which means that that span should occupy this many pixels within my optical train, within my camera. Oh, look, it does. We can now reject the idea that there is any lens happening whatsoever, because a lens that doesn't change the angular size of something is not a lens at all.
Well, okay, then what? I'm gonna post it just one more time, just so for reference. But then why the angular size is different for the oil rig? For the oil rig on the right on both images, the angular size of that oil rig on the right on both images is obviously dramatically different on the picture on the left versus the one on the right. So how could you only use angular size to determine? Are you using this to determine distance? You said.
No, I'm not. I'm not using it to determine distance. Okay.
Well, would you agree that the angular size changed here, even though the distance didn't change?
Yes, but I would also argue about their camera. I'm assuming this was done with either a Nikon P900 or a P1000.
I think these are Bose pictures. Yeah, like BLMSMB 60. Yeah, that BLSMB. I forget the exact. I could.
Okay, so
but you know that channel.
And this is why I want to make this very, very explicit, is that depending on the movable lens of either the Nikon P900 or the P1000, which I have both at my disposal, it's very, very hard to get the same zoom on two different days because that lens moves. And even though there is a digital indicator that will tell you roughly how many millimeters of focal length you can zoom to, that position is based on an electric motor. And that motor may not be accurate enough to get it at the exact same location every single time. That's problem number one. Now,
Can I just interject really briefly? This is his channel. It's BMLSB69. I think I
Okay.
got it mostly right. But anyways, that's his channel.
right.
I think it is a P900, but I'm not. I'd have to double check that though.
It's probably one of the two. But then the question then becomes, hey, why would that problem not exist for your scopes? Because my scopes do not have that type of movable lens apparatus. Once you assemble the optical train, you cannot change the focal length. They are locked together. So if you keep the same adapters and lenses and everything screwed together and that kind of thing, you will have the exact same focal length every single time. So let's say, for just the sake of argument, that you go up to the mountain, you make this measurement, and you see that the angular size does not match prediction. Ooh, that's a problem. And if that does happen, and if the lensing effect is such that we actually see that, then you would be totally justified in rejecting every single measurement that we make. But let's hypothetically say we don't see that, and the optical trains are locked, as I mentioned previously. We don't see that. We make our measurements of the angles. They are consistently over 180 degrees. Everything is pointing to a particular direction in this case. Would it then be satisfactory if we made that additional measurement with the angular size to make sure that there was no lensing effect happening?
Yeah, no, I hear what you're saying. Is the goal with the angular size, is that to evaluate distance? Or
No, that's only to evaluate lensing. So if at a particular distance and a mountain is predicted to have a certain angular size, well, that's underneath the assumption that you're not looking at it through any sort of lens or whatever. So if I know what the span of my telescope's field of view is, I know what angular size fits into that optical train, I can then say, okay, then for each pixel that I'm seeing, it equals this amount of angular size. I can just count the pixels of how many pixels wide that object is. Now I know the angular size. So if the topographical maps make a prediction based on where you are, and that prediction turns out to actually be the case, that would only work if no lensing effect was even occurring. So no lensing is occurring. So we have eliminated lensing as a concern. It is not happening, which means we can trust our angle measurement, which will be a totally separate measurement. We would trust that, and then we would do it multiple times in a day, and then we would do it in multiple different locations, and then we would do it multiple times a year. Would it
No, I got
then
you,
be
but that's why.
satisfactory?
But that's why I posted like I think Extra J. I think he just tagged you in it. I think he took one. He said both platforms have different angular sizes, and that's what I was saying. Now this is down low to the water. You were mentioning a P900 effect. I mean, that all could be discussed. But I mean, obviously the angular like shape and size of that oil rig on the right does change. It's dramatically like warped. So when you're talking about like taking angular size like to a mountain, or I hear what you're saying, trying to like check that. Are you suggesting that when that's done, it always matches? Because I mean, in this case, obviously it wouldn't match, unless there's some argument that this is like a unique situation. But there's a lot of other places on Earth where this occurs, where you get certain mountains that, like, in relation to mountain peaks, sometimes one that's further will look lower down, other time it looks higher up. And that's why I think like the one argument I mentioned Xana, because it really brings this one up a lot. And in my view, it's kind of like cherry picking it when the mountain looks like it's lower, like the whole Ranty photo with the Blackpool Tower and the mountain behind it. That to me is like a cherry picked. It's like one condition in which, yeah, that does match the rate of what the globe curve would be. Now, if that was always the case everywhere on Earth, that could be compelling, but it doesn't seem to be the case. It seems to be that it varies, and that now we have a refractive effect, which is even why a similar concept like where the horizon is and how much it's cutting off, even on a lot of the globe claims, is that it's a refracted horizon at this point. Like we're never actually seeing the curve; we're always seeing a refracted position of it.
Well, I'm just gonna say this because I want other people to get in. I don't want to just hog everything. I have already agreed at the very beginning of this that the platforms have a different angular size. But if you remember, I had an explanation for that. It could be the case that the P1000 was at different levels of zoom, which would change the angular size. What I'm saying is that we wouldn't have that problem. We can guarantee that we were at the same level of zoom because our optics are physically locked together. You cannot change the focal length of our telescopes unless you completely rearrange the optics. So if we have our optics literally screwed together in the same order every single time, we can be confident that our focal length is the same every single time. I do not believe, even for a second, that that was the case with the platforms, which perfectly explains why we're seeing two different angular sizes. So we wouldn't have that problem. He's most likely
So
dealing with
you
that
think
problem with the P1000 or the P900 because I have a Nikon. I know it's quarks, both of them actually, and it's very difficult to get that.
Yeah, I got you. No, that's an interesting rebuttal. For sure, like that it could have to do with that. I myself don't know that I know that we've studied these pictures quite considerably. I would have to pull up like the rest of them and kind of compare to figure out which ones these two are, of whether they are at a different zoom. The thing is though, I mean the water like on the left is like covering both of them, whereas the water on the right, like you know, is extended out. So I mean, whatever's happening, like even if someone said on the left, oh, that's the curve of the Earth right there, that's the water, the tip of the ball. Well, obviously the one on the right, the horizon, and that's the whole like black swan, what people refer to as black swan, you know, that whole argument too. But we're also talking about the position changing and the angular size. So there's a few things happening. The horizon looks like it's either further or beyond the oil rigs on the picture on the right, whereas on the left, the horizon looks closer and it's like cutting off both of them. And then I hear what you're saying about the zoom thing. I'm not sure if it is different zoom or not, because I know what you're saying. It could be a different zoom and then they just cropped it differently or whatever. Not sure on that. But and
I
then
didn't say cropping
also
is a good thing.
the oil rig on the right is higher or lower on both, and it's wider and fatter. So there's like multiple things going on in there. And so
This is why it would be imperative that we make these measurements multiple times, because you're right. There may be some atmospheric fuckery going on, which is why we would do everything in our power to make sure that the data is clean at the end of the day. And the only way that you're going to get a satisfactory answer is to do this over and over and over and over and over again. Now, I would argue that, and I'm going to use finger quotes here, I'm not saying this as a slight against you, but just let me get this out. Any reasonable person would probably be satisfied doing this over a week at the same location. A slightly less reasonable person would probably want it in two different locations. But I went way beyond that. I did multiple locations, multiple times of year, and even switching the order so that we do that same order again at a different time of year relative to each individual location. But it seems like that, again, would not be enough. It just wouldn't be. So if that's the case, and it would require us to literally build the greatest structure in flat earth debunk history, and it would have to be something that you can physically touch and slap and that kind of thing, you know, maybe ride on like a little horsey or whatever the fuck, then I guess we're done, because I can't build that structure. I can't. I don't have enough money. I don't have enough materials, and I bet you I could not find people that would be willing to sell me their land to make that shit happen. Some of it is probably protected property. So we're fucked.
yeah. Okay, so I hear you. Now, let me ask for you. No, because everyone may answer it differently. Like what's, you know, that like that word definitive, like what's definitive or exclusive when we're talking about like the actual shape or the contour of the ground.
Well, I said
Now
satisfactory.
for you doing these mountain peak long distance observations, if you said you've already done it multiple places, that's awesome. If you did it in even more and you were able to that it's you're consistently getting greater than 180, what does that do for you? What does that conclude or resolve or answer for you in your viewpoint? I'm just saying, if we take it, let's say it's all measured exactly like it's said. Let's just say for the moment, like, because there's the whole thing of questioning whether you actually do measure this greater than 180, and especially having it be consistent with greater and greater distances, not just cherry pick locations. There may be some that are going to debate that, but even if for the moment we just accept that it is a thing, what does that do or conclude in your mind? Because like I said, to me, even if that was confirmed to be, it doesn't necessarily mean the ground is curving. It could have to do with the medium, and that's why Jeremy got into, you have to actually measure the path of light to confirm, is that light actually curving at the rate of a sphere, or is it actually not? Essentially, and understand how that path of the light is actually comparing to the physical ground to know which one's which.
Well, I already answered that, and I don't want to sound like a broken record. So let me just answer the main question. What it would do for me is that it would indicate that the globe made a prediction, and that prediction turned out to be the case. It would also tell me that the flat Earth also made a prediction, and that prediction turned out to not to be the case. So of the two models that would be up for consideration, the globe model was the one that came out on top. If we were to put them together and we said, okay, they both make predictions. Now, which one best comports with reality? We go out, we make the measurements. We probably do it in multiple different locations. That's fine. And then I can safely conclude that of the two models up for consideration, the globe won. And I can say that with definitive energy.
Okay, so for you, if all the greater than 180 optically from mountain peaks over long distances did show, you already feel like it has, but if you do think 100% that it does show that, you think it concludes that the ground does have a sphericity to it?
Yeah, I would be comfortable saying that. I would also go further and I would say that because we were able to do it in multiple different locations, the evidence is even stronger than if we had done it in one location. And if we did it over multiple different days throughout those multiple different locations, then it becomes even stronger still.
No, I hear you on that. Always doing more is better for sure, especially on the Earth where there are varying conditions and so on. So that's for sure. It's to replicate as many times as possible. I don't think it does always get those effects because like some of these things I'm mentioning about the angular size, the widening, the changing. I mean, the horizon thing's a different kind of whole topic, but just the way that things over distance can look, yeah, like that Blackpool Tower type scenario. Because there's other spots on Earth that are the same distance to Blackpool Tower, and Blackpool Tower is the same height. And then the mountains, like there's other ones that are similar to where it doesn't match the globe prediction. And then in those cases, the globe says, oh, well, there's a refractive effect happening here. So it is kind of refraction that's like claiming that the light is essentially bending in a way that relates to a globe Earth. Now, I do hear you. If you were getting the greater than 180, that is showing something. But what about this? In your conclusion of that, what if it is something to do with the medium, the atmosphere, the air, whatever you want to call it, everything above the ground, basically, not the ground itself, but not the ground itself, but everything above the ground. Now, if that effect was a real thing, that again, just taking that for granted that it is measured, and you did it in a bunch of spots, you confirm that. If it actually was an atmospheric effect and not that the ground was curving, are you concerned that concluding that the ground is curving would have been a faulty conclusion?
Well, if we didn't safeguard against that, then yes, I would be concerned. But in this conversation, I mentioned multiple safeguards that we could implement to make sure that such a thing wasn't corroding the data to the point where a reasonable person would not accept it. So what are these safeguards that I mentioned? Well, one would be the predictive capability. What should we expect to see if no lensing effect occurred? That was number one. Number two would be a lensing effect would obviously have impact on the angular size of our target. We can measure the angular size, compare it against prediction, and if the prediction turns out to actually be the case, then we know that a lensing effect is not actually occurring, which means that the atmosphere is not fucking up our actual azimuth measurements, and therefore we can be confident that our azimuth measurements are therefore correct. Now, if we didn't have any of those safeguards in place, a person would be warranted. A person would be reasonable to question us, I would say. They would be reasonable to question us, but because we do have those safeguards in place, it would be more reasonable to not even bring them up.
Okay, so can we go through them one at a time real quick? Hold on, Robert, before you jump in. What was the first one?
So the first one was the predictive capabilities. If we had a lensing effect that was completely fucking up our azimuth measurements, then that means our azimuth measurements could not make any predictions. So if we went to a completely random spot, which was not one of the three locations in which we originally made our measurements, and we said, okay, if our measurements are true, and we know the exact angles to all of these different points, then this completely random point over yonder should be well outside of the predictive capability of these measurements. My measurements predict it's going to be in this direction. I'm going to tell my telescope to point in that direction, and I'm going to ask the observer, do you see the laser pointing at you? And if the observer says, yes, I do, then that means my prediction was correct.
Okay, so I just wanted to go through them really quick one at a time. So the first one, the predictability. I'll just give like really short, quick rebuttal, like kind of more as like a thought experiment, because I haven't gone out and done all this myself. Obviously, I don't have thousands of my own first primary observations. So we can all find stuff on the internet and things that other people have claimed. That's cool that you've done a few of them. But I'm saying I don't have like thousands of my own. I have some, but I don't have all of the, to be able to have that at my fingertips. But just with a preface to that. So the first one of the predictability though, again, if we just take it as a thought experiment, let's say that the effect is measured consistently. Let's just say that that it's, and so on. Now the predictability part, there are discussions about how that 3,959 mile, the radius of the sphere, the globe, is essentially that radius is actually a part of our vision. Now, what is that part? We could get into all that, but that's a whole separate thing. But meaning that 3,959 is actually a part of this realm of how the human eye works. I'm just leave that all generalized for right now, because we could get into all the details, but I'm just saying, just to kind of give the idea of what I'm saying. And so if it was an effect of either the atmosphere or our vision, etc., whatever that combination is, and if it functions like a 3,959 hemisphere, for example, just as a speculation in that sense, like just for the moment, if it functions as that, then the predictability of a 3,959 number would be consistent. But is that 3,959 number actually confirming the radius of a said sphere Earth, where the Earth is actually a sphere, or is it confirming something about, let's say, the radius of our vision, for example? And like I said, without getting into all the technicals of how that could or couldn't be happening, I'm just saying, like, if that was the case, the predictability, the first one, that would be my rebuttal, is that if it's a function of our vision and or atmosphere, that predictability would also be there, because that would mean that the 3,959 is something real in our world. It's just like, what is it real of? Like, what is it actually, what is the real, effect of that? Is it a planar Earth with the optics that cause that, or is it that we're on an actual sphere? So that's the rebuttal of the first one. And then if you remember or if you want to respond to that, but I know you had number 2 and 3. I just wanted to respond to them one at a time, because you did lay out 3 things.
Yeah, in order for me to actually respond to that, you would have to tell me the mechanism, because I bet you whatever mechanism is being asserted, it's a testable mechanism. But since I don't know the details, I'm not going to be able to respond to it. But let me get to the second one. The second one would be the angular size thing that I mentioned. So it was mentioned that, well, the target could be made larger or smaller or anything else like that. True, that is a possibility if this lensing effect were to actually occur, but we can test if it's actually occurring. The way we do that is with the angular size of whatever mountain that we happen to be looking at. So if via topographical maps, which can be independently verified, if via topographical maps it is predicted that this mountaintop would have an angular size of X, we can see within our optics if that actually is the case. Now, if it turns out that what is predicted to be the case without any lensing turns out to actually be the case within our optics, then we can state conclusively that there is no lensing occurring, since a lensing would dictate a change in angular size.
Okay, so a response there, I would not necessarily say that a lens would denote a change in angular size. Now, when I said lensing earlier, I think I did say it more in like a generalized speculative fashion, like meaning not like a dead set claim of some kind of physical lens. Now, I agree with you that, I mean, some lenses could change the angular size of things, but others will not. Like there's this one little video I have, which is, it's like showing a rainbow. It's like raining outside and you see clouds and there's a rainbow. And the guy takes 2 polarized lenses, and as he twists them, the rainbow just disappears. But then the rainbow comes back when he twists it back. And then he twists it, the rainbow disappears. So like in that case, there's not really any angular size change, but there surely is a lensing effect. Like the actual polarizing lenses are changing whether you see the rainbow or whether you don't. It's kind of amazing because it's like the rainbow just disappears. Like it was there and then everything else is still there. The clouds, the house that's there, the ground, you can see everything else. It's just the rainbow that disappears because the polarized. So, I mean, that's just one example of lenses that wouldn't change angular size. So if we are kind of talking about some kind of lensing effect, it wouldn't necessarily change angular size of things.
Yeah, but keep in mind, one, I would say that's not a lens, that's a filter. Filters are not lenses. And secondly, the original claim made by Jeremy, which actually sparked this whole idea of a lens, was specifically about changing the size, because he said those words explicitly. So if we're talking about a lens that does not change in angular size, then the original objection is voided, because a lensing or a lens that does not change in angular size will have zero impact on our measurements, whether it's there or not.
Okay, well, I don't know if Jeremy's still. I guess he's not on here right now. So I don't really want to.
He's not. So I'm
Well,
not.
I don't want to fully respond.
I'm just going to say it was brought up. I'm just going to say it was brought up, and so given the fact that what was brought up was some sort of lens that exists between observer A and observer B that would literally change the angular size, therefore having some sort of fuckery with the path of light, we can test to make sure that is not actually the case. And that is by using angular size predictions, because the prediction is based on no lensing whatsoever. It's just straight lines and trig. If there was a lens changing the angular size, that would we would be able to detect that within the optics that we would bring with us. That would be my rebuttal to that.
Okay, but are you suggesting that the angular size of things is always consistent?
No, I'm not saying that. What I'm saying is that if it were to change, we would know about it. And that way we can be very, very cautious, or we can say, hey, if we took measurements, we know for a fact that they're not reliable. So we would stop. We wouldn't even do the measurement. Why waste our time? We would go to Denny's. We would go to Waffle House. We'd spend our time doing something else.
Let me
But
jump in.
if we
Let me
don't
jump in
see
before I
that,
lose it. Hold on. Let me jump in before I lose it. So, okay, I think I understand what you're saying. You're basically saying that let's say you went out one day and you did the spherical excess, but you also do the angular size thing. And let's say one day you get 180 degrees and you don't get any crazy angular size warping or anything. Second day you do it again, you get 180. But then the third day you do it and you get 181, like 181. You're like, what is going on? And then you pull out you do the angular size and you're like, oh my God, it's a totally different angular size. Is that what you're kind of linking? Like the idea that like, if there was something like that happening, it would be immediately linked or correlated with an angular size change. But that's kind of assuming that whatever the effect that's causing the 180 is also the effect that's linked to angular size. They may or may not be related.
we would disregard that particular day of measurement. But I would even go even further, because I am so confident that we will never see such a thing. I think such an idea is complete and total horseshit. That I would say that even if we saw it once, even once, I would say this entire methodology, no matter how many times we did it, no matter the locations we went to, it would not be good enough for me if we even saw it once. But since I'm so confident that we're not going to see such a lensing effect, we're not going to see such a dramatic shift in angular size as what would be required with a lensing effect, I'm not worried about it. So I'm willing to put that on the table. If we see any lensing effect in one instance, the entire methodology goes out the window. All the data is garbage. All the data is tainted. It will not be enough. It will never be enough. But since I am confident that won't happen, I'm willing to put that on the line.
All right. Well, I mean, you're okay. Well, I mean, I think the angular size of things does change. Like there's all kinds of like warping effects that can happen, especially over long distance, at least to some extent.
Not to that extent. Not
But
to
either
that
either
extent.
way,
The
though,
only way
that's
that
not necessarily directly linked to quote unquote like a lensing, that it would necessarily have to be related in that way. Meaning there could be an effect, a 3959 effect of like, let's say we see in a hemisphere, and
I
as
don't
you
know
get
the
to the
methodology
extent
there.
of it, you're actually picking up sort of like a meniscus, but it's a meniscus of the ether, of the atmosphere, not the ground.
Okay, but again, I don't know the mechanism of the imposed 3959 rather than just the geometry of our planet. If it's something beyond the geometry of our planet, I would need to know what that 3959 is in this particular framework. If one cannot be provided to me, I'm just going to say it's the geometry of our planet and move on with my day. But to this particular observation, and to the last point that I said, I'm willing to put that on the table. If we go out one day and the angular size is not what it is predicted to be, and that lensing effect is detectable, I would say the entire methodology can get thrown in the garbage. But I am very confident that Jeremy is wrong to suggest such a thing happens, especially to that extreme that it would totally fuck up our measurements, that I'm willing to stake the entire methodology on the line. I will sign my name to that. So if we go out and we do these sanity checks. Let's call them sanity checks. We know that our laser can match predictions. We know that the lensing effect is not happening. We can then be confident that when we do our azimuth measurements, they're actually measuring reality and not some distortions that are out there.
I want to quickly say something.
Go ahead.
Geo, you cannot introduce a radius effect or value of the eye, the human eye. You're going to have to validate it. You're going to have to point to biology that points to a radius value of the eye, the human eye, right? Because you said you wanted to replace the radius of 3959 of the planet with the human eye's radius value. You're going to have to dig up biology and show us where the human eye is 3959. No, you mentioned the ether, right? You cannot introduce things if you don't have something to substantiate it. That's what you're trying to do. You see what I'm saying? So what the gentleman is telling you is that everything points back to the radius value of the planet. You cannot introduce ether without something to substantiate that it can replace 3959. Thank you.
Yeah, but the other side is saying everything is reducing to the limit of your vision.
We have optics for that. Optics are much better than human eyesight. That's why glasses are a thing too.
So we can use optics and spot the geometric horizon.
If we can use optics to spot a lot of things, which would include the horizon, yes, if we really wanted to. But keep this in mind that we're not talking about doing this at the beach. We're talking about doing this on a mountaintop where the air is probably thinner, probably a lot colder, probably a lot drier than the beach. I'm talking about doing this in the middle of Colorado or the Appalachian Mountains in North Carolina, not the beach.
Yeah, well, since we can't spot the geometric horizon with optics, and the horizon seems to depend on which optics you're using, it's not unreasonable to say that optics are a more viable explanation.
Well, again, we're
than,
not looking at the
the
horizon. We're
falsifiable
looking,
geometric horizon value.
well, again, we're not looking at the horizon. We don't care about the horizon in this observation that we would be doing. We'd be looking at mountaintops. And if we have 3 observers at 3 different mountaintops making mutual measurements of one another's location, we can get valid data off of that. And we can ask, okay, given the information that we got, given the measurements that we got, in the light of our sanity checks, of course, which model best comports with this data? We can ask ourselves that question. And I'm going to bet that the globe would be the one that it comports to. Now, some people may not be satisfied with that for whatever reason. I think it's safe to say that Geo may not be satisfied with that. But if he ever does change his mind and he says, you know what, after thinking about it, there are enough checks, there's enough sanity checks, there's enough safeguards in place where we can be confident that the measurements are valid and that they would indicate something is actually the case, I'm willing to do this. I might be willing to squeeze some funds together and probably do some crazy shit.
How does it more comport with a globe if a globe requires a geometric horizon and we can't spot that with any optics? The apparent horizon just moves based on your optics that you're using, right? So that kind
The
of
globe,
more comports with the personal dome
the
position.
globe makes more predictions than just the horizon. Okay. Yes, the globe makes a prediction that we'll even have a horizon, but we're not looking at the horizon for this. The globe makes other predictions. And one of the predictions that makes is that if you were to do this particular type of observation, you would get angles more than 180 degrees. So if the globe makes that prediction and that's what we get, then it shows that the globe made a prediction and that prediction turned out to actually be the case. The horizon's irrelevant there.
Yeah, the horizons are relevant if you don't try and look for the geometric horizon. But if you do try and look for the geometric horizon, well, you can't spot it with any optics. All right, so that comports better with the personal dome of vision position.
The personal dome of vision is just some nonsense that Jeranism now has, well, he came up with it originally, Jeranism did, and now he has disowned it as a
It's
concept.
not really nonsense. I mean, do you have a limit to how far you can see?
You're talking about the law perspective, right?
I'm asking, do you have a limit to how far you can see?
Yeah, it's the available resolution of your eye, but I have optics that can
Okay.
increase the available resolution available to me.
Right. Yeah, I didn't ask you that. But you have a limit to what your eye can see, right? So you have a personal dome of vision.
No, that's
Yeah,
horseshit.
every direction you look, that limit is gonna make a dome of vision around you. Right?
No,
You can
again,
extend it with instruments
no,
and tools, yes.
you're
You
you're
just
you're
have a
you're
larger
wrong.
dome of vision.
No, you're wrong because that dome of vision would
Wow.
indicate that there is a distance limit. I can see objects 5 feet in front of me. I can see objects 400 kilometers in front of me. I can see objects 93 million miles away from me. What dictates whether or not I can see it is the angular size and the available resolution of my eye. That's the only thing that matters when it comes to whether or not I can see it. It's not the distance. So saying that we have a dome of vision is literally nonsensical because I can see the space station with my naked eye. Now, I can't resolve any features, but I can sure as shit see it with my naked eye. And I've measured the altitude, size, and speed of the International Space Station. I know it's 400 kilometers up, which means I can definitely see something that's 400 kilometers away. Okay, well, can I see anything further? Yes, I can see the planet Mars. And I also personally measured the distance to Mars. I know that at the time that I measured it, it was 80 million kilometers away. Well, now the limits of my dome vision or whatever is now 80 million kilometers. But wait, I also measured the distance to the sun. That's 150 million kilometers away. So now I guess the limits of my vision are 150 million kilometers. Now the numbers are getting so big that it actually doesn't fucking matter what they are.
Yeah, I agree. The distance doesn't really matter, especially when you can't prove it, right? You haven't actually put a tape measure out and measured it, right? So things could be a lot smaller and a lot closer. You have no way
No,
to
that's angular
differentiate
size.
between the two.
We didn't use angular size to measure the distance. We used parallax, which cannot be fooled via the angular size of an object because we're not measuring that at that particular moment in
Yeah,
time.
parallax doesn't measure distance either. It
Actually, it
measures
does.
angles. No,
No,
you're measuring for the angle that's the parallax angle, not
it actually
measuring for a
does
distance.
measure. No, angular size can measure distances if you know the baseline in which you made that measurement.
Yeah, but you
It's
said
alpha.
parallax, not
Yes.
angular size. You said parallax measures distances. That's not true.
No, it is. It is. It's alpha equals 2 times the
No.
arctan of g over 2r, and you simply rearrange to find r, which would be the distance to the object.
Okay, then you wouldn't be solving for the parallax angle. It's a different measurement.
No, parallax indicates that there is an angle at the very top of the triangle, which can also be the angular size of an object, but that's a different story for a different time. If I know that parallax angle given the baseline, I know how far away it needs to be in order for it to have that angle. It's literally just trig.
All right, but if you're, measuring the parallax, you're looking for the angle of parallax. You're
Yes,
not looking. You're not looking for a distance.
yes, if you find the angle, you also found the distance as a consequence because the angle that you measure is a consequence of its distance.
Is it?
Yes, it is. That's how perspective works.
So I mean, but you can have the same angle of parallax and it be 2 inches or be two
No, you can't.
miles. Yes.
No, you can't. You would have
Yeah, you
to
can.
you would
It's
have to
called scale.
drastically no, you would have to
Have you heard of
drastically
scale?
nope, you
You
would
know, I
have
think
to
scale.
nope, you would have to drastically change the baseline. If the baseline is consistent between two different measurements, I can tell you with 100%
What do you mean
certainty and
baseline?
confidence the distance between the two observers. Hold your finger out at arm's length.
The two
Blink.
observers.
Yeah, that's how we measure parallax with two observers. There's two telescopes in that measurement. You didn't know that?
No, I didn't know that. There's two observers. Where are the two observers?
Spaced apart by some distance. That's the baseline that I was referring to. It would probably be easier if I brought up a diagram. Let me bring up a
So two
diagram.
observers are involved in parallax measurement. So you can't make a parallax measurement by yourself, is what you're saying.
Correct. You can only make an angular size measurement. A parallax measurement would require two observers because it's the concept behind depth
Well,
perception.
it doesn't require two observers. It requires an observation from 2 points with a distance between them.
Yeah, exactly.
And for planets, it does require two observers because you would have to make that measurement simultaneously. So it does actually require two observers explicitly. So here
No, what
is
do you so there has to be an observer what like on the other
I'm
planet? That doesn't make any sense.
no, I'm showing you a diagram. Okay, can you see my screen? I'm sharing it. Can you see my cursor moving?
No, hold on.
Click the
Okay.
feed.
Okay.
Wait, so
All right.
but are you saying that if you had a camera set up in one location and then a camera set up in another location, but you're the only one looking at the cameras, then it wouldn't work?
No, because that would still count as two observers. The cameras would be the observers in this case. Just because one person is controlling both cameras is no different than me telling two individuals to hit the shutter at the same time over the telephone. So
No,
anyway,
you can
anyway,
measure parallax just from
anyway,
a
so
single
here
observer,
you
one person.
can you see this point that I'm
Mm.
circling with my cursor? That's observation point 1. This point that I'm circling with my cursor is observation point 2. So this gentleman right here measures here. This other guy measures here. By measure, I mean takes a picture. He takes a picture of Mars. Okay, well, let's see what that means in practice. We get these two images of Mars. Okay, I see Mars right here, and I see these stars. I see Mars right here, and I see those same exact stars. Okay, well, what happens if we overlay the coordinate data between the two? Oh, look, there's a shift. It changed. That's the parallax measurement. So if I get the parallax at 0.00150.702 degrees, I can then do basic basic trig. So if I know my baseline, which is the straight line distance between observers, I already know what my angular size is because I just showed you the 0.00150.702 degrees or whatever the fuck. And I also know angle A, so which is this angle right here. Let me back up a little bit. So we have angle A, we have angle M, we have the length of the baseline. We can now solve for x, which would be the distance to Mars in this
Wait,
case.
where are you getting these distances from?
Hang on, let me, I'm showing you the equations right here. So I then...
Yeah, but where'd you get all these you got all these values just from the parallax angle?
No, I got all these values elsewhere. I'll tell you that in a moment. But just for this, assuming that we have the baseline, assuming that we have the angle A, assuming that we have the parallax, we can
A lot
figure
of
out the distance x, which is 80,980,483.62 kilometers. That is this distance, length x. It's basic trig. Now you ask, where did I get the baseline? Good question. I got the baseline by looking at angle E. Oh, but that just begs the question, where did I get angle E? I got it by using either astrometry, where you can measure the stars over each observer and measure the angle between them, or you can use coordinate data. But either way, I found the coordinate data, which is it equaled about 22 degrees was angle E, if I remember correctly. Yes, there it is. Angle E equals 22.608159 degrees. So
you
you
still
can
have to
either...
assume the size of Earth.
Nope, absolutely not, because we
And
were
what's
actually...
that? Okay.
No, absolutely not, because here in this video, we also measured the size of Earth. Here you can see observation point 1. Here you can see the length of the baseline that we were using. Here's observation point 2. And then if we take these two observations and plug them in, 360 divided by 0.04333 degrees times 3 miles, which was the baseline, divided by 2 pi, we get 3,967 miles, not an assumption, a measurement.
We have to go back to the parallax angle because you said
Okay, let's go
from the
back to that
parallax angle
video.
alone, you can't get any distance. And that was the whole argument.
No, you can, because you can go further than
Without
just looking at the
assuming,
parallax value. A
without
parallax
assuming
value
distances
has a
for your
consequence.
variables. Can you
So
go
if you
back to
know,
that?
if you know if you know the parallax given the baseline, you know the distance.
If you know the parallax, so once
Which we
you
do.
measure the parallax angle,
Which we do.
and then if you assume a baseline,
No, a
you can then.
measurement,
We
not
said if you
assumption.
know the baseline, okay, then where did you measure the baseline?
Okay, good question. So what we did was we measured the radius of the Earth, which is this part of the video. Then we figured out exactly where we were on that planet. Let me
That's what I was
find
saying.
the
You need to know or
Oh,
assume the
hang
radius
on,
and
hang
size
on.
of the Earth.
You
You
have
said
to
it
let
was
me
wrong.
you have to let me finish. Again, we already figured out the size of the Earth at the beginning of the video. We already established that. That's done.
What?
That's dusted. So
How is that
if
tested? How is that
so
established?
given the fact that we now know
Wait,
for a fact the radius of the Earth, i.e. the size of the Earth, we
how
then
was
say,
that
okay, if
established?
I'm
That
located
part.
here on this part of the planet and he's located there on that part of the planet, what's the surface distance? What's the
Wait, how
surface
was the
distance?
size
So
of the Earth
along the surface
established
of the
here?
Earth. So if I know the surface
Hello?
distance, that means I can figure out angle E. And if I know angle E and I know the radius, I can find the baseline because that's just an isosceles triangle, my guy.
Are you trying to explain it to me? Because like I'm asking you questions and you're just talking
Well,
over me.
in order for you to actually learn, you have to listen to my entire answer and not just
O-
interrupt
Okay,
me
but you're
halfway
jumping
through.
all around. It's like very
No, I'm actually
disjointed
staying
and
on
not very
point. No, I'm
coherent.
actually staying on
And
point.
yeah, you're skipping over the relied upon assumptions. So that's what I'm trying to get at.
Well, there was no relied upon assumptions, and if you had
Well, you
listened,
said
you
you
would have
already
realized that
figured
they're
out
not
the
assumptions.
radius of the Earth in the beginning of the video. How did that happen?
So what I did, once again, was we looked at the North Celestial Pole. You see this telescope right here. This
Okay.
telescope has very accurate motors within it. And these motors can report back to me what the altitude angle is, okay? So how accurate are these motors? Arc second precision. Do you know what that means?
Yeah, well, so far I've heard angles. I haven't heard any
All right.
measurement
Cool,
distances,
cool.
right?
I'm
So,
glad that you know what that means. We then, hang on, I skipped ahead a bit. Oh, skipped ahead again. God damn it,
and
this
wait,
fucking...
do these motors, do they have the
There we
Earth size assumptions already baked in, or No,
Nope, they were just measuring angles. So then
it's just
we
angles.
have 3 miles. We drove 3 miles. We take a second measurement at a different location, and we
Uh-huh.
see the North Celestial Pole, and we measure the shift. Okay,
Uh-huh.
we found that shift. So let's
Uh-huh.
go ahead and convert these to decimal degrees so they're easy to understand. So in location 1, we had 27.11972
Right here, I
degrees.
see an issue. So
At location 2, we had 27.07639 degrees. And we
I
had the
see an
distance
issue already.
between then we had the distance
But do you
between
want
the
to pause
telescopes
because I already see
at
an
3
issue?
miles. Hang on. Then we had the distance between the locations of 3 miles. Okay, now we have all the information we need. So we take 360 divided by the difference between these two angles, which is 0.04333 degrees, times that by 3 miles, which was our distance between the two, divide by 2 pi, we get 3,967 miles. Within a few, what was it, like 3 or 4 miles of the accepted radius of the planet? Nice. That's how
Okay,
we got
so
the size of the Earth.
we got the two angles, elevation angle measurements, right? 3
Mm-hmm.
miles apart.
Uh-huh.
And that's all you need to get 3967, I
Yep,
guess.
there's the math right there
Okay.
for you. So now that we have that, we can then say, okay, given that we know the size of the Earth, we can use our position on the planet to find the angle, or I'm sorry, the baseline. So if we know that I'm located here in
Wait, what
Colorado,
happens if you
and
drove 6 mile baseline?
it wouldn't change the answer.
Are you sure?
We would still get 3,900, whatever the fuck, 57, 3957, or whatever the fuck it was.
Oh, so if you wait, so it keeps getting more inaccurate the bigger baseline you get, it should get more
No,
accurate
because
your baseline.
if we drove further, then the angles would be different, and it would still equal when all is said and done to that same exact value. The values wouldn't remain the same, and we change the baseline. The baseline is literally tied to the values themselves. The baseline literally determines those values. We're just measuring what they are, and then we're
Well,
What he's saying is measurement accuracy is less important with a bigger baseline. The
is that what he's
baseline
saying?
the baseline does determine the level of accuracy depending on the accuracy of your measurements.
Yeah, but it would be the opposite. A larger baseline increases the accuracy, not a smaller one. A smaller base
That's what he said. He said a larger baseline would increase your accuracy.
Yeah,
that's what I would assume.
a larger baseline would increase the resolution and therefore the accuracy of our measurements, but 3 miles is all we needed because our telescopes are really fucking awesome.
Yeah, but I mean, it didn't even yield the proper 3959 value, and then
That wasn't important to
you don't
us.
even know what would happen if you had a larger baseline. You sounding
That
kind of
wasn't
confusing.
that was important. You say 3959 is what it should be. Well, one, I assume you already know that that's just an average. In fact, the distance is different if you're going north to south or along the equator. There's a bit of a bulge there. You may know this from Neil deGrasse Tyson and the pear-shaped bullshit that you guys like to go about. So you know that it's not a consistent measurement all the way around. That's point number one. Point number two is that we wanted to measure it for ourselves and use that within our calculations. So if you want to say that 3959 is wrong and in actuality 3967 is correct, I'm more than happy to make that compromise with you. 3959 is wrong, 3967 is correct. Doesn't make that much of a difference when all is said and done.
All right.
So anyway, moving on. So if I know the size of the Earth, which we just went over this multiple fucking times, I can figure out, okay, what is the length of the baseline? So let me do this real quick. Why is this thing not working as it should? YouTube is really glitchy. Okay, so here is the angle of our baseline. This is going to be angle E in our diagram. So if I'm located here, I can look at some stars over here. If I'm located here, I can look at some different stars. Now I can measure the angle between those stars. The angle between those stars is literally going to be the same exact angle as angle E right here. That's method number one. Method number two, which is completely separate, is using our position on the planet. If I know how far I need to travel along the surface in order to get to the other location, I can use that information to find the direct route, which would be right underneath the Earth. So it'd be a straight line distance. That would be this. See how this baseline kind of goes under the surface of the Earth? We can find that length via that trig, via angle E, which we can find directly, and it's found here. So here in this equation is angle E. Here is the radius in kilometers that we personally found, and that equals this baseline, 2,502.731797 kilometers. That's how we can get that baseline. How we can find angle A, which is the angle between my visual line to Mars and the baseline back to Astronomy Live, who was the person I was working with on this. I did this in a cheating type of way. I used this 3D calculator. So I plotted my points in 3D space and I just had the calculator measure the lines between them because I was lazy. But as you can see, when you plot everything out, it comes out to 58.32763 degrees. So we have angle A, we have angle M, and we have the length of our baseline. This is all we need to find length X. And finding length X is the distance between Astronomy Live and Mars. And when we do, we find that length X is 80,980,483.62 kilometers. So going back to what you originally said, what is this dome limit vision thing?
What the personal limit of your vision? How far you can see in any direction?
Yeah, because apparently it's not 80 million kilometers, so what is it?
Well, I mean, it's going to be different depending on the atmospheric conditions and what optics you're using.
Okay.
But still, yeah, I'm still stuck on the baseline to the 3 mile baseline to Earth's radius.
What are you stuck on, like specifically?
So yeah, so I mean, well, so on a sphere, wouldn't that line be curved, the 3 mile baseline?
No, it wouldn't. That's why we
And then I
measure the
feel
radius.
like, yeah, if you extend that out, like it's gonna mess up the map.
The curve is what gave us the angle shift. So it wouldn't be straight, it would be curved. That's why we measured a radius. That is some good OJ. So anyway, Geo, think about it, mull it over, sit on it, dream about it, talk about it with your significant other. Let me know if that's enough. Icy Spin, quick question for you. Someone looking from the outside in, if you are still available for comment. I will take that as a no. Okay, never mind.
What's the subject?
I don't know, come up with something.
Is it true that somebody tried to accost you one time from this community, Red, in person?
I don't know. What? I need more information.
That you were in some public place and then someone tried to come up to you or something like that. That was from this community, and
Not that I know of, no.
no, never mind that.
There was that one time with what's his name? Southern Israelite. He's a flat earther that also believes that the South was not seceding because of slavery. But anyway, he said that he was going to come to a rocket launch because he was like upset with me or something. And so he literally bought plane tickets to show me that he was serious. And then he like thought that would scare me or something. And apparently he's like, oh, well, I actually canceled the plane tickets. And so I'm not going to do it. I just did it to scare you, to let you know that you should be, watching out. So I offered to actually pay for his plane tickets that he had just canceled, and he never got back to me. But that's the closest it's ever been. I miss Southern Israelite. He was fun.
He had like a photographic memory. He could remember all kinds of random stuff.
Southern Israelite?
Yeah, like he would have like direct quotes that he'd have memorized.
I'm sure he has plenty of time on his hands. Plenty of time to memorize a lot of shit.
Well, hopefully you feel more welcomed every day in the Flat Earth community and face less hostility. I think there's probably danger on both sides. There might be some unhinged people within Flat Earth, but definitely within the globe, there seems to be some sort of probably inherent danger as well. Like, let's say if you get in the way of whatever the globe is trying to push, perhaps it could be a dangerous thing for anyone or enterprise. For instance, you guys probably disagree, but during the first moon,
definitely do, yeah.
Okay, just hear me out for one quick moment. During the Apollo 1, if I'm not mistaken, Gus Grissom died tragically, and there was an investigator. He was a NASA contractor and a safety inspector, if I'm not mistaken. He had how many pages was it? Several 100-page report, and he took it to Congress. And 6 days later, he also died, and not just him, his, I think, wife and stepdaughter. So there is a theory that the moon landings didn't take place, and those people who were maybe kind of telling people, maybe trying to be like whistleblowers, they were silenced. So seems to be some sort of potential danger going
His
against the
report got
government.
out though, right? Like they didn't kill him before he got his report to Congress. Oops.
Yeah, they sucked at it then. It's like, oh,
Yeah.
we cannot let this information get out there. Information gets out there. Fuck. Well, if killing him was supposed to prevent that information from getting out there, the mission has already failed. Fuck it. Let's get rid of useful personnel and kill him anyway.
Okay, how about this
He might
one? They
release the
have
report.
the level of information access like they do now. Like with Microsoft accessing our computers, potentially Microsoft can know exactly what or government agencies could know what we're planning and what we've
Talking about
gathered.
Flock.
Back then, probably not as right. They had that information gap, perhaps.
If they were as all powerful as I believe you fear them to be, they wouldn't have contracted with Flock Safety to install all these fucking AI cameras everywhere. It's like, why would they need that shit? They already had tabs on literally everything, and apparently know enough about if you know too much, we can whack you. We can send some.
Silence. Yeah.
We can send some people in dark colored SUVs to make sure that you never speak a word ever again. It's like, no, the government was incompetent then, and they're incompetent now. I bet you can give them the best tools in the world, and they're still gonna fuck it up. I mean, just look at Edward Snowden. He was able to whistleblow the entire fucking operation of the fact that the government has access to your dick pics. So if you've ever sent a pretty lady, someone that you're very fond of, a dick pic, I got news for you. The government has that dick pic, and they have saved it at maximum. In fact, they had that dick pic before your girlfriend did. How does that make you feel?
That's pretty funny.
Yeah, they
I
were
mean, I've
able
always
to get
wondered though.
access.
I've always
They were
wondered
able.
though.
Oh, go ahead.
I was gonna say, I've always wondered in the flat Earth community, though, right? This is a grand conspiracy to where even all the countries that are pretending to be in conflict with one another still have like a secret pact where they're not willing to disclose the information. It's such a critical, important thing to world security that all the countries are in collusion to hide the shape of the Earth. Yet, when the grassroots movement of the flat Earth started up with like Eric Dubay and Matt Powerland and
Mark Sargent,
Mark Sargent, and the priest that died. What was his name?
Bob Nodell.
No, the priest guy.
Oh,
Oh,
Rob Skiba.
Rob Skiba, yeah, etc. Like, why didn't the Men in Black just like accident them, right? Like before they ever got any traction going, right? And shut down their YouTube channels and just disappear the internet stuff that they had produced.
They would have been very easy to whack. The government had that capability. I remember that all you had to do is send a few dark colored SUVs with really, really, really tinted windows to their properties, which can be easily found with subpoenas and shit like that. Go into their property on the guise of a warrant and just oops, my gun misfired.
Well, some speculate they had a different safeguard in place rather than assassinating.
The flat Earth doesn't have any fucking safeguard. They had conventions, my guy. They went out in public. Jeranism actually went to one of these flat cons or whatever the fuck they're calling it.
They don't do black helicopters anymore. I feel like I haven't heard about the black helicopters in a minute.
Okay, how about this then? Let's say that the Earth is
black
flat
SUVs.
and there's a momentum building, right? You're seeing debates in elementary school, debates in high school. And what would you do to stop it? Are you willing to go to the length of potentially releasing a weapon?
Here's the thing, though. Apparently, this was such a huge, international conspiracy secret that, like, you would think they would have had like guardrails in place that literally the moment that you uploaded a flat Earth video, like, and it started getting any views at all, like, they'd show up at your house immediately, deleted from YouTube, and you'd never be seen again.
Yeah, and also it wasn't really working all that much because when Jeranism was pushing demonstrably incorrect flat Earth bullshit, he was able to elevate his channel to over 100,000 subscribers, and I was barely getting past 35,000 subscribers. So yes, I got traction. I have a decent-sized YouTube channel, but Jeranism was able to eclipse my numbers by over 3x, and we started doing this shit literally at the exact same time. like down to the day, because I made my channel the same day that he made his channel dedicated to flat Earth. So on the day that he made a channel dedicated to flat Earth, I made my channel dedicated to debunking his sorry ass. Literally happened on the same day. And he was able to get over 100,000 and I was only able to get over 35,000.
Probably because at that time on Google it was trending flat Earth, so anybody within the flat Earth community would have been probably
Probably, but
seen a lot more.
the higher ups, the nameless, faceless, they would have just stopped that trend. They would have modified the algorithm to make it so that no one would even know that that fucker even existed. But the only reason that he hit the algorithm and it was able to spread as far as it did was because YouTube wasn't doing anything to squash that shit, and most especially the government, which is kind of underneath their thumb since they rely on the government for quite literally everything.
You do know that
you want that merger? You want that merger? Well, here's what you're going to do. You're going to kiss the ring, motherfucker, and you're going to do it with unbroken eye contact.
Yeah. Okay, what about this then? The government did, if I'm not mistaken, hold some sort of congressional hearing or some sort of hearing with some of the CEOs or people from the tech industry, and I think they were quoted on asking them on what they were going to do on specifically two things: one, misinformation, and two, flat Earth. If I'm not mistaken, they did literally say flat Earth.
Yeah,
so
and that went
I
to
think there
shit
was
thanks to
action for them to
yeah, and
start.
that went to shit thanks to the Trump administration. Since you had the CEO of Facebook, the guy that looks like a fucking android, he said, "Oh, we were too heavy-handed, and now that Big Daddy Trump has allowed me to allow bullshit to spread on my platform, I'm going to go ahead and do that. I'm literally going to announce that we are disbanding our quote unquote trust and safety team or fact checking team or whatever he was calling it. It's literally a wave between administrations. So to say that there's this concerted effort and it has never changed, nah. It all depends on who's in charge and whether or not they feel the need to actually push for something. I got news for you. This government absolutely loves the amount of horse shit that's currently spewing on every social media platform. They love that shit. They're actively promoting it. Trump himself is posting AI slop.
Okay, and my last question. Thank you guys. I'd like everyone's feedback on the globe side, if you want. No pressure. Even if the Earth is a globe, which you guys think it is, what aspect would the government lie about, like maps, in your opinion? Because let's say it is a national security interest not to give accurate information about the globe to state enemies. Because, like for example, you wouldn't want to maybe give them the entire proper map of your land because they might find weaknesses. So, what do you guys think? What would they lie about if the government had to?
They wouldn't be able to hide it.
Yeah, it's so easy to procure that. There's just no way to hide something like that. Now, they try to hide, like, supposedly you'll get shot on sight if you try to, like, go inside the hangars at Area 51, right? Like, they try to hide whatever programs they have running there.
Yeah, but like the actual shape of your continent and where major cities are located, you can't hide that because let's say you can't get that information directly from the United States. They're just going to go to some other superpower that has their own satellites to take pictures. I mean, the Chinese have their own rockets and spy satellites. The Russians have their own spy satellites. Multiple European partners have their own satellites. They're launching out of French Guiana in South America. So they can go to... So if a bad actor wanted that information, they could just buy it from one of them.
Mark Rober from YouTube put up a sun synchronous satellite. I mean, Mark fucking Rober. I mean,
That's badass.
The thing is, though, I don't think America. Okay, doesn't each nation or continent have their own satellite system? So America's satellite systems potentially are above America, and then Europe has their own
No,
sort of.
they go over the entirety of the Earth. They orbit.
They're all
over
on polar orbits. Yeah, they're all on polar orbits, and they're photographing the entirety of the Earth multiple times a day.
So you
think they're allowing China satellites over America?
It happens all the time. The Chinese space station goes over America. You can literally see it happening. I haven't gotten an image of the Chinese space station because I'm more interested in the International Space Station, but I could get you that image if you would like. The Chinese have their own space station, and it goes over the United States multiple times a day.
It's small though compared to the ISS.
It is small, yes, absolutely. It's not as impressive as the International Space Station. That is true.
Do you think they had some sort of agreement, or do you think China's probably just flexing muscle, saying you can't stop me?
It's the second one. They were banned from going or being a part of the International Space Station. China said, "Fuck you, we'll just build our own space station," and they did. So it was a giant fuck you. You're absolutely correct. It was a giant fuck you to the United States. And you know what? Point taken. That was a pretty substantial fuck you. Good on them. Good on them.
Yeah.
They
Returning favor, I guess, with the ISS potentially going over their land. So
they wanted to basically show their capabilities in space. Now let's be clear, their space program is basically a copy of a copy of a copy, since their spacecraft looks exactly like the Russian Soyuz, but with some minor tweaks here and there. But still, give credit where credit's due. They were able to make their own space program, have their own space station, return samples from the fucking moon. They did that. So they have a pretty successful space program, which goes back to the original thing you said. If they wanted images of the United States, they have the capability of doing that themselves.
it's an interesting thing to consider for sure.
I mean, that's why they're building. I mean, that's why they build their own jets. They have their own rockets. They have their own satellites. Now, I think the J-20 is a piece of dog shit compared to the F-22 Raptor, but it might give a F-15 or F-16 a run for its money. I'm willing to accept that. Also, I don't like the canards. The canards look weird.
Okay, and then what if there were scientists on the globe side that maybe they don't want a young Earth, so they're going to promote an old Earth? Because if they promote perhaps evidence of a young Earth would align with the Bible, and maybe there's some people that don't want to have any sort of any part of their belief align with the Bible, even if it's only one aspect. What do you guys think?
The
Because
big
there are scientists
the
that say
Big
that
Bang
the
and
Earth is young.
the
The
Big
globe.
Bang and the finite age of the universe aligns with Genesis. So if they're trying to hide the Bible, then they would have never said that that the universe had a beginning and it has an age. The assumption before the evidence of the Big Bang was that the universe was eternal. That was the mainstream cuck, as you guys would call it, mainstream cuck science answer, was that the universe had been around forever. So when they got evidence to the contrary and evidence that actually comported with Genesis, why would they have ever said that if they were trying to hide the Bible?
Yeah. And also, a quick question: does this aircraft look just off to you? Does something about it just not look right?
Yeah, looks like maybe one of the rear fins, the bottom one there.
I
What are
mean,
your thoughts?
this is the J-20. It's kind of their answer to the F-22 Raptor, and it's got canards, which are the small wings on the front. I don't know, it just looks weird. Just want to
Looks
throw
like
that
it's
out
that
there.
try hard that has a mohawk to be edgy, and then yeah.
That's funny. But yes. So anyway, the point is that the Chinese can do some shit. So there you go. So the Chinese can do some shit. And as far as the indication of God, you have scientists out there that will say that yes, the universe is billions of years old, but they just use that to show that God really is timeless, and you're not going to knock God out of them by simply bringing up the age of the universe. They just use that as evidence to show that God is timeless. And if God really did set the initial spark into motion to make all this shit happen, I'm perfectly okay with that. I have no horse in that particular race. Literally none. I'm agnostic when it comes to the existence of God.
Amazing. Do you think so? Are you angry? Let's say if God is real, are you angry with the way he designed it and how
I
you
think
perceive?
I think designing wisdom teeth in the way that they are was a pretty dog shit move. So maybe I would have some questions for the guy. Like, hey, when you were designing the human body, why did you put testicles in a position that were so easily kickable? Could you like answer that for me?
Yeah.
What was the logic behind ass cancer? Can you answer that for me, please? If like there's so many things, like why did you make my nose and my throat like connect so that I can choke to death. Like, I have a few questions. Maybe God has a sense of humor and just wants to see us suffer. Who knows? Maybe he's totally indifferent and we're just pawns in his game. It's anything's possible at this point, I guess.
Yeah, I wonder if there are more things to be thankful for than things that we find inconvenient.
Like wisdom teeth.
Yeah.
And how it can lead to a tremendous amount of pain.
Oh, for sure.
Or getting kicked in the
Debilitating
testicles.
pain. Yeah.
And I would also call ass cancer more than just an inconvenience.
No. See, it was a stroke of genius because he knew by the time they came in, you'd already have rotted a few teeth out.
So he was just making room.
Why should teeth rot in the first place? Sure.
That's because you're nasty. That's why. You're nasty.
Reds, how did you end up in the Northeast from Florida?
A job opportunity.
Oh, okay.
Yeah, I do not want to be here. The weather sucks. The cold sucks. The salt on the road sucks. Everything sucks. The drivers here suck so bad. But God fucking damn it, the money is good. So I took the opportunity. I do miss Florida though. So I go back whenever I can.
Where are you, Boston now?
Boston, yeah. Boston, Massachusetts.
You're coming up on 4th of July when they're going to fire the can on that old ship,
probably.
right?
I'm unfamiliar. I mean, I'm not from here, so
well, they have
unaware.
They have a ship that's like the oldest active service ship in the Navy. It's like built in the 19th century.
Interesting.
I forget what the name of the ship is. And then I think it's on 4th of July. They sail it around the harbor and they blow the cannon and set off all the
Maybe I'll
alarms
check
in
it
the street.
out. Yeah. I would be lying to you if I said I did a thorough exploration of Boston proper. I've been like around the outskirts, so like that would be like the 95 and the 495 loop. I've been around there, so like Natick, Framingham, Needham, Worcester, which the locals called Worcester. And I was like, the fuck did you just say? That's literally how it's pronounced? Yeah, it's pronounced Worcester because reasons. Braintree, Quincy, Weymouth, Brookline, Needham. These are all weird ass fucking Dedham. They named a fucking city Dedham. Like the place is fucking weird, but I'm slowly exploring. I'm assuming Jake, you're from Boston or something like that?
No, I've just been a couple of times. It's the USS Constitution, by the way. It's a museum. Yep, and they sail it every 4th of July out into the harbor and they fire the cannon.
Maybe I'll check it out. There's a Boston Harbor Hotel.
And they have a lottery for the public to get a ride on it when it sails on the 4th of July.
Neat.
How far are you from like downtown Boston, like the Boston Commons area?
You can find me like around the Newton area.
Oh, I'm not real familiar with that.
If you were to
is that north or south?
It's neither. It's to the west.
Oh, okay.
So if you wanted to do like a straight drive, assuming that you didn't have cataclysmic amounts of traffic, you can probably get to downtown Boston in less than 20 minutes. Of course, this is assuming no cataclysmic amounts of traffic, which there usually is.
So you've never done like the Freedom Trail through Boston, all the historic sites, like?
No, I haven't. I've actually been
Bunker
spending
Hill and all that.
No, I've been spending most of my time actually in Rhode Island in Charlestown. I spend most of my time there.
That Boston weather is terrible. I've never been. I've just heard. I had a friend that went to Harvard, so I've only been there in the summer.
It fucking sucks. It sucks. It absolutely sucks.
They had one year where they had so much snow. God, this was like probably around 2015 or 2016. They had so much snow that they literally had nowhere else. Like normally they just push it up the side of the road, right? They had so much snow that they literally had no more places to store it. It was a total nightmare.
Yeah, it was a clusterfuck. This last winter, it was a total clusterfuck. My car was buried up to its roof multiple times. That fucking sucks. But if you want to know where I'm like spending my time, it's Charlestown, Rhode Island is where I've been spending a lot of my time.
It's a short drive to New York too.
Yeah, I don't really like New York too much. And in my opinion, New York is very, very much overhyped. Like there's a park where you can get the Frosty Drew Observatory. And that's where I go for my telescope sessions. It's one of the few truly dark areas since everything around here is light polluted as fuck.
I mean, I think New York is just, I mean, it depends on what your expectations are, but it is a pretty cool city. It's just got so many amazing restaurants and bars, and It's always bustling, even at like midnight.
Oh, I agree, but you can get that same exact experience in Boston proper or in Worcester. Like recently, I went to Worcester to the Palladium, and I saw a concert there, and it was fucking awesome. And after the concert was done, the traffic just getting out of the parking garage was absolutely terrible. It was gridlocked to shit. So I said, "Fuck it, I'm not going to stay in line for 2 hours burning gas. I'm going to explore the city," and it's pretty dope. I'm amazed of how many restaurants were open at 2 o'clock in the morning and just how many people were there. Met up with some people, made new friends. That was great. The concert at the Palladium was absolutely amazing. So that was a great show. So yeah, good stuff.
When you were in Florida, you were like, were you an insurance adjuster or something like that?
No, I didn't do insurance ever. All right, you guys are going to have to make a decision for me. So first one to answer wins. Option number 1, Taco Bell. Option number 2, Denny's. Option number 3, Domino's.
They're all
What are we thinking?
horrible.
Absolutely. I'm looking for peak garbage for this evening. So what fits that criteria the best?
They're all tempting in a way. I
Pretty
used to
sure
go with
they're-
my friends to Taco Bell every now and then and Burger King, but do you like soft shelled or hard shell tacos?
I'm thinking if I were to go with Taco Bell, I would go with the cheesy gordita crunch. That's a colon cleanser right there.
Nice.
That will give you the runs like no one's business. Who needs laxatives when you got Taco Bell?
Yeah.
So I was thinking either the Dorito taco or the cheesy gordita crunch. I'm feeling that. So your suggestion is Taco Bell, right?
Yeah, I'd probably go for that. It's been a while.
All right. We're going with the Diarrhea Canyon. So good stuff. All right. I'm gonna go make a very poor dietary choice. In the meantime, you sexy bastards have a great rest
Placebo.
of your night.
Yeah, you too, Reds. Thank you. Well, I'm not gonna give up on Reds. I'm gonna try my best to convert him to a flat earther and a Christian flat earther.
He told you exactly how to do it.
Yeah, I was on the road at the moment, but I might have to rewind. And I'm not giving up on you guys either.